Video about Eugene because Jake here, you said a quote by Osho.
Yes, living begins where fear ends.
Exactly. So you live on the, the life begins at the edge of your comfort zone.
Everybody felt
You start making your own choices.
beginning of the great experiment.
Start taking your own risks instead of other people's risks.
Exactly. Shame there's no.
I'm here in one of the largest ranches in the Northwest. Today, it's Rajneesh
There's no
Firm
subtitles.
because a prominent Indian
But
guru
it's
and his
fine.
followers bought it.
Our vision was to
Yeah,
create
dude, this
a
is something we gotta do.
Based on
Eventually,
compassion and sharing.
find some like
Demonstrate?
land, yeah, and create a community that becomes a city.
Of humanity, that was
Uh,
his
Yeah.
goal.
And proves that it works.
Yes, exactly. And I feel like, unfortunately, he walked so that we can run.
has a place for these people.
Oh, totally.
Because you said he got.
Standing on the shoulders of giants.
Exactly.
Yeah, you're right.
You said he got attacked by the CIA, right?
He was, I believe, incarcerated. I'm not sure, though. There's a bunch of claims. The whole documentary is about this, so I'm not going to spoil it.
Bomb went off in the middle
Do
of
you
the
know if
community.
he's still alive?
60 followers
Oh,
evacuated.
don't know.
Catastrophe.
Could Google it, but I don't care.
Yeah.
It's alive in me.
We'll do that
I
later.
didn't
Because
take
imagine if we
measures
could add
to
him
protect
to
our
the,
community.
imagine if we
Dude,
could add
if
him.
I mean, if we could get Osho, I mean, Osho's got a huge following. You wouldn't give a fuck.
The government
Exactly.
Probably-
That would be amazing.
they're going
Yeah.
to get you.
Oh,
Hey, Osho. Hey, Osho. Osho, if you can hear me right now,
For a big outbreak.
hey,
contact.
it's Jake. You know,
They had no evidence.
as if I ever fell out of contact with you.
Yeah.
Did
You met
He
this
knows.
this close to murdering a presidential?
Have
Oh, you're so simple. You're so simple.
There is bias,
Oh.
there is prejudgment.
I'm talking in
there is
metaphor.
discrimination, and this is
guy? Well,
democracy.
yeah, but
I've had enough
then.
of it.
So chill, relax, yeah. So it can make it obvious.
We
Yeah.
will
Chill.
be ready
But if
to
you've met
protect
him
ourselves.
before, that's one thing. But if you're trying to contact someone you haven't met before, it's better to be like, yeah, like imagine them and be like, yes, let's meet so that we can work together.
There's no first meeting. Hey, hear me. Hear me. There's no first meetings.
Doesn't make you a bad person.
I've already met everybody.
Yeah, well, that's true. But there is like, it's all about context. It depends on the context at which you're speaking.
Yeah,
Yeah.
that's correct.
So yeah, so for what I was meant was in the context of like the fact that yes, we are with him and we're friends with him and all that good stuff. That's great. That's awesome. And in the future that will be the case. But right now, as we're recording this and experiencing it, the context is not that. But it is
Future
on another
is
level.
here.
Yeah, it is. It's on.
Future is here.
Yeah. I'm still.
Here the future.
I'm trying to keep us in the context of our
Stop.
our bodies.
Stop doing that. Yeah, stop trying that.
Well,
I'm trying to break your context.
Yeah. So relax a little bit. Let's not try to break it.
I am relaxed.
Let's go with the flow.
I'm the relaxed one here.
Yeah. Let's let everybody do what they want to do and feels best. Let's go with the flow. So anyway, as I was saying, so that looks pretty cool. I'll check out that trailer later. And now you wanted to watch the video about Waves by Eugene.
Right.
All right.
Yes, this video, we're going to have so much to talk about because the metaphors are spilling out of it.
Yes.
It-
Yes. So we got
Everything is metaphor.
We got to yes, but we got to explain what the metaphor means to those who don't understand it. That's our job. Is to
Right.
Is a
translate the
wave of
metaphor.
electric and
Yeah.
magnetic
Oh, yeah,
fields.
yeah. Okay, I got to watch your stream again. I fell out of it again.
Oh, okay.
Here we go. Okay, I'm in.
Yeah. Can you hear it?
Even the background music this time.
Sound
Yes.
is a
Oh,
wave
you
of
can
air
even hear the
pressure.
background music. That's great. So yes, waves. The universe is made of waves. That's all the universe is.
According
It's
to
just-
quantum mechanics,
Just
all
listen
the
for a
particles
sec.
in the universe
Just
have
listen.
the properties of waves, including all the particles that we ourselves are made from.
Beautiful.
Therefore, to understand light, sound, and the very nature of reality, it is necessary to first understand waves.
Yeah, and toroids. Like that example, that is a
Is necessary-
those like expanding and contracting things are toruses for the audience.
to
They're
first
not. They're not
understand-
Tauruses.
Yes, they are.
You're incorrect.
Well,
No, they're not.
yeah,
You don't know what a Taurus is.
I do. It's like a donut. But it's a.
It's not a
toroid.
donut.
It's not. I mean, a donut is in the shape of a toroid. What I'm saying is they're toroidal fields. Everything, all waves are toroidal fields.
You're being a word cell right now. You're using words that you don't understand to make it seem like you understand. Stop doing that.
I respectfully disagree. I know what a Taurus is. What makes you say? Okay, tell me why these aren't Tauruses. Because
it's. I can tell you what it is instead.
Okay,
it's not a Taurus. It's a pair of spheres.
Yes, they're spheres expanding and contracting. Unfortunately,
Yeah, a sphere is not a Taurus. A sphere is not a Taurus. Okay, let's just get that clear. A sphere is not a Torus.
No,
they're
because
different.
they don't have spheres don't have holes in them, so you couldn't
Yes.
like topologically. However, what I didn't say, if I said toruses, I didn't mean toruses. What I meant was toroids, and that they work in a toroidal like pattern. The pattern of expansion and contraction of spheres and cycles of spirals moving in and out is what I was saying.
Yes.
So let's
just say that then. Just say that because when you say toroid, it triggers people. It triggers people.
Yeah. Well, people who
makes them think.
Yeah. But that
people who think they understand. Dude, mathematicians don't say toroid. Well, we do sometimes.
That's true.
It's just not how it. That's.
You're right.
Confusing.
It's
confusing.
I don't want to be. Yeah, and that's exactly
like you
what
said.
I want us to communicate and understand.
Like you said, we're trying to build a bridge, so we
Yes.
have to be very clear and slow in how we present our thoughts. Right?
Do you?
The meter.
Yeah. Do you understand what I meant now, though? When I meant that.
Yeah.
Okay.
Once you explained it, I
Yeah.
totally understood.
Perfect. Yes. Toroidal fields are the wave like I believe to be the wave
And
sort of
waves.
shape of the universe.
I'm with you, man. I feel your sentiment, but I'm just, I'm doing what I gotta do.
Yeah, it's just.
I have no
it
choice.
sounds- Yeah, it's not. Well, you do have choice. That's the key.
Oh,
You.
I
don't.
don't. I'm not present. I'm not present right now.
And give
Distracted,
yourself
I'm not
up
present.
To love,
To understand
you
the
do.
properties
But the
that
thing
all
is,
waves-
like, are you if like when you understand that when you speak in metaphor, that's also confusing sometimes to other people too, right? Like
Can be.
Yeah.
I do understand. Yeah.
So how you felt when I said when you heard Taurus from my mouth is how I'm feeling right now when you're saying that you're not here presently, because
Correct.
we're all here all the time on some levels in some context, but on a level of context, like as long as all context, as long as we start from love and we come here and we choose the source of love and connect to the earth and the universe and the sun and everything through geometry and fields and waves. Yeah. Breathe.
Can we meditate? Can I guide you in meditation real
I'm
quick?
down here. Actually, sure. Can I guide you in meditation afterwards?
Of course.
All right, cool. Perfect. So you go first and then I'll go second.
Right. I just learned this one the other day, and I thought it was fun. It's a gift I'd like to give you. So
Thank you.
you don't have to close your eyes. I don't do closed-eyed meditation.
Yeah, it matters neither way. Whatever's comfortable.
So let's just start off taking some deep breaths. Just get kind of present, just nestle back into the present.
Yeah, feel them all.
Yeah. Ever present now. I was always present, right? We know this. Okay, now I will ask you to close your eyes. I can't tell if you are or not.
My eyes are now closed.
Okay. Now imagine for you, stretching off into the horizon, there is a road. Now-
I'm imagining a road as best I can.
Oh, perfect. That's all I'm asking. Now, start walking down that road. We're walking down the road together. You can even be holding hands if you want. I love holding hands.
We're working together.
Yeah,
we could be
we're
going for a
cooperating.
jog. We're like, we're jogging.
It's a little bit more competitive. It's a bit more competitive
Not
because
in
one
a
of us is.
competitive way. Only in competitive towards yourself. We're jogging at the same speed. We're jogging together, but we're doing it as a sort of like exercise.
Yeah.
Yeah.
Okay,
We
I
can
love it.
still
I love
even
it.
be
We're
holding
jogging.
hands. Yeah.
Yeah.
We're,
We have many hands.
Exactly.
We
Yeah.
have infinitely
we're like
many
Hindu
hands.
gods, so we're good.
Exactly. All right, we're Hindu gods. We're jogging down the road.
Yeah, we're jogging down our path.
Can we be running down the top of the Great Wall of China?
Sure, why not? Well, the Great Wall of China or a
Yeah.
imaginary one that's
The
okay.
uh,
All right.
Yeah.
So we are.
Okay.
All right. So our Hindu gods are jogging, nicely.
Oh, I'm not jogging anymore. I'm on a horse. I'm on a horse.
Yes.
Coulda.
Sure.
Okay.
And
And
I'm
off
as
now.
long as we, are maintain the peace from the meditation, we can ride and run whatever we want.
Right. Now, okay, so we're just trotting down the Great Wall of China and looking out into the expansive wilderness. Those beautiful mountains.
Yeah. On
You
either
see.
side, or like in front
Oh.
and behind us, or the whole.
You tell me.
Yeah.
What do you see?
Well,
Tell me.
I see the path since we're on the wall, which is raised, elevated above the ground. I would see the mountains and things on the side, and I can see the different tower pillar, like the what are they called, the turrets that are that bring the tower piece together. But yeah, so I can see the mountains and feel them and everything on our sides as we're jogging across the Great Wall.
And now as we're going, see, oh wow, this part of the wall is broken. What?
Okay.
Let's go explore it. What's down there?
All right. So broken in the way that it's like just a crack, or like it's like we can't pass
It's
it.
falling apart. Have you played
Oh, okay.
Dark Souls?
No, but I've seen gameplay of it.
Okay, so imagine it's like this
Here, do you want me
huge
to
part.
What do you know the name
Oh,
of
no.
this? Oh, okay.
Don't do this.
Okay.
This is outside of the meditation.
Well, because I was gonna.
This is only imaginary.
We're still live streaming, so if anyone's watching, if
Yeah.
anybody wanted to see what you were talking about, I was gonna look it
If
up.
anybody wanted to see what I was talking about, they'd be listening to what I said.
Well, yeah, but whatever. Anyway, so there's something that's there's something.
You're so
that's-
eager to talk, man. You're so
Yeah.
eager to talk. Just be silent for a minute.
Anyway,
Listen
yeah.
to me.
Go ahead.
Are your eyes literally still closed?
I closed them again. Yeah. They were open.
Matter. I
for
don't give a
bit,
shit.
But now, yeah.
I don't care. I literally don't care.
Yeah.
You can do anything. You have free will.
Exactly. I do. So let's not tell each other what to do.
Yeah, exactly. I do. So, exactly. I have free will. So, it's not free will, bro.
How is
It's not
that
free will. You're not relaxed.
Bro,
It's not free will. It's just will. It's not free will. Just will. You have tendencies. You tend to do shit.
I think that a lot of
Patterns.
issues and things come from describing other people's problems instead of worrying about our own issues.
Well, do you know that the Buddha said you must release yourself from all dogma?
Exactly. Yeah. So let's worry about ourselves, and you can guide me through the meditation, and I will listen.
I'm not worrying about shit.
Yeah.
You can tell me to worry all you want, but I'm not worrying about anything.
I'm good, because I literally said don't worry. Yeah.
Yeah. But it also comes with the implication that I was worrying. That you were. I'm just saying, like, we're not worried right now.
Good. Then we're perfect. So we found this this broken piece of the wall, and
So we're gonna go down. We're gonna go down this huge section of the wall fell down, like a mountain slide of rocks and
okay,
bricks.
So a big pile of stuff, refuse.
Yep. So we're gonna climb down those. We're gonna climb down. And whoa, this is weird. There's actually like a jungle down here. Are you seeing this?
Yeah.
The jungle?
There was a jungle on either side of us, so we've climbed down the wall, and we're seeing the jungle in front of us.
This is wild. I love how rich and vibrant the colors are.
Yeah.
See that? Like how the green is so green. It's like the sun just
Trees,
bounces off those
bounces through
leaves,
the
you know?
leaves, yeah, and you can hear the
Yeah.
birds chirping and the
Ah, oh, I can hear them now.
making their
I didn't hear them
noises.
until you said that.
Yeah, we're there. We're standing there. You
Yeah.
you still on your horse and me standing next to you? I suppose I could have a
Oh,
horse as well. Why not?
I got off. I gave you my horse. I got off my horse. You can ride it now.
Well, here, we have our horse
Yeah.
with us. We're both walking, and the horse is
Yeah,
coming with
we
us.
have a horse with us.
Yeah.
Yep. Okay, so it's you, me, and the horse. We're walking.
And-
Whoa, this is weird, but there's actually a path leading into the jungle.
Oh, wow.
So let's follow that
All right,
path.
so let's
Yeah,
go
do you
there.
see that?
Yeah, let's
follow the path.
I see it as like a twisty, winding thing through the, the trees and the rocks and things.
Yeah, okay, we're walking down the path. I see something up ahead. You see that?
Yeah, I see what looks like
Is that an animal?
Oh, an animal. Okay.
Oh, a temple!
Yeah,
There's an
I
animal
was-
guarding the temple.
Oh, okay. What's the animal?
Oh.
I see an elephant.
I think it's a
but-
tiger.
Okay, a tiger. It
Both.
could be both a tiger and an elephant, or a combination
Or-
of the both of them.
Yeah, what's the difference?
Yeah, it's just a meditation. Although I feel like it is getting a little bit. It's getting a little specific. Here, you were the one guiding the
That's the
meditation,
point.
so
That's-
I'll let you take the guide. So we're
Thank you.
going along the path, and the tiger's here.
Yeah,
And,
and oh wow, what a beautiful look at the way the muscles ripple through that tiger.
Yes, it's a very.
Oh my gosh. Ah, it's just its eyes. I'm mesmerized by its eyes right now.
Yeah, I'm imagining it sitting like a cat, and you can see its
Yeah.
like eyes looking in it.
It's a very noble creature. Like,
Indeed.
to me, the tiger knows its royalty in the jungle.
It is the apex
know.
predator of the area.
Is what it has to be, that right? That's just how it was born.
There was it is what it is as is. All is as it should be.
Yes, but you know what I find more compelling than the tiger's royalty? Is the elephant's gracefulness. It's so gentle and graceful.
Yeah.
Even though it's one of the largest land animals, it's so graceful.
It's giant.
Oh my
It's
goodness.
a gentle giant, and you can pet its side and feel its trunk and everything.
Wow.
And the lion and the elephant are laying down together, and they're at peace. They're partners. They're the spirits of the temple.
Hmm? What do you think's inside of the temple?
That's a good question. Why don't we go inside?
Let's do it. How about this? Now it's your turn to guide the
All
meditation.
right. I see. It's like a pyramid-shaped temple, but with like 4 like Tibetan-style like turret things around the side, and in the middle it's got the Hindu, with all those relief patterns. And on the inside we see one of those like Shiva standing on one leg doing her or his thing. I keep saying Shiva as a girl, but Shiva's a guy, I believe. I'm not sure.
Shakti
Shakti
is Shiva's consort.
Yeah, exactly. Yeah. So Shiva. Anyway, but again, we're all just meditating, and so we're getting the most. So Shiva is dancing, or even another one, surrounded by more statues of the many-armed gods that are of Hinduism, showing the path of enlightenment and understanding that we are the universe and we are just different faces of the one reality, so that we may view and interact with ourselves perfectly. And then
Yeah.
and as we walk up the steps with the elephant, with our horse, and the elephant and the tiger, they gracefully follow us. It's like a red carpet almost that is leading up the stairs, and then leads into the room where we see these statues surrounded, and we can find these pillows that we can all sit on, where you and I sit across.
Finally. Oh, it's so comfortable in here.
It's beautiful.
You smell the incense burning?
Yes, yeah. Would you like to take over? Go ahead.
Oh, I smell the incense burning in here.
Yes.
It smells like cinnamon, and I smell cardamom. Oh, wow, this is so spicy.
Yes.
But the cushions, look at how the cushions are embroidered. Cushions
They're
are
so-
embroidered.
Yeah. Beautifully.
Thought it was my
beautiful.
turn. Is it my turn or your turn?
It is your turn. I'm sorry. I'm actively listening by
Fine.
I apologize.
Perfect.
Yeah. Go ahead.
Don't apologize. We're perfect.
Yes, we are.
Please.
The embroidery.
Please
within
don't apologize.
The things. Thank you.
So,
I was just
Wow, this
commenting on
isn't-
the beauty of the embroideries. Continue.
wow. And I'm going to just go ahead and plop my ass right on one of these cushions in here.
Yeah.
Oh, whoop. Oh, it's so comfortable. We've been walking for so long.
Yeah.
My body is so sore. I just wanted to sit on a cushion, basically,
Just
you know?
fall into it like a cloud. Oh, that's awesome.
Finally. Finally. It's been so long.
And if
I feel
may-
like we've been here before.
Yes, we are probably spirits of the temple as well. This is something we built.
I think you're right. Oh, you are right. I remember now. I remember now.
And I can
Now I
feel-
remember.
Here, if I may make a suggestion, I could also imagine
Of course.
the seats, the cushions are in a large circle. There's many cushions for as many people want to join, but they're also the horse, the elephant, and the tiger have also joined us in a sort of like a square formation, or like a pentagon. Where there's 5
Pentagon.
Yeah, so like you
Yes.
and I are like across, and then there's the horse between us, and then next to us there's the tiger and the elephant, and we've all
Yeah.
sitting across the room in a sort of pentagonal shape, creating a like a pentagram of energy that we can create.
Yes,
So we
that's
can
correct.
enhance our meditation.
Finally here. This is what it was all coming down to. So, yeah, we're finally sitting on our cushions, each the perfect size for us.
Yeah.
Feeling the embroidery.
And you can, if I may take another lead, we can
It's your
feel
turn.
a light from the sky, a beam come down from the sun and light up the room like there's a hole in the ceiling, and it fills us up with light rays, and we can see the dust and things, and it connects all the way down to the center of the earth. There's like a pillar, like a line that not quite drills, but connects us to the earth in the center, and we can feel the roots of the trees around us, and all of our desires all the way through the mantle, through the crust, the mantle, and everything, all the way to the molten core, the heart of the earth. This is a place of beauty and peace.
Yes. Oh, I love it here. This is where my home. I think I live here.
Yes, this is our home. This is where we are meant to stay when we wish to reside and remember.
Yes.
And in
Residence.
the middle,
It's our residence.
Yes, it's our residence. It's a place. It's one of our many places of residence, because the whole world is the whole universe is our residence. We are residents of the universe.
Oh, here.
And
I got a zinger for you. Ready? Everywhere is your home, but here is your residence. Right
Yes.
now is your residence.
Yes.
Everywhere is your home, but now is the residence.
Everywhere is our home, and here is our residence. And thank you to ourselves and the universe for creating this residence that we may reside.
Man.
Express so
Amen.
much gratitude. Thank you
Oh.
to the lion and the elephant for letting us in. Thank
Yes,
you
thank
to this
you.
temple. Thank you to this connection to both the earth and the sun, and all throughout the universe. And of course,
I'm just immersed in gratitude right now.
me as
Oh,
well.
wow. Oh, I feel so centered here.
Doesn't it? Yeah.
I feel in balance. I feel like I can find my center of gravity here.
Yeah.
I always
And
lose
we
sight of my
achieve-
center of gravity.
Yeah, it's and you can always regain it back. Remember to just connect to the core of the earth. Let it stabilize you. Let this temple be a reminder of your stability and your core and your ability. Our minds are infinitely in the universe throughout all time and space, but remember that our heart, the core, is within love, within the core of the earth and the sun and the temple, and just love, just universal, unconditional love. Tethered
Love it.
to, connected, giving and receiving and gratitude,
Synchronized.
synchronized.
Harmonious.
You want to hear a cool guided meditation if you don't mind? It's like
Oh, I don't mind at all.
excellent, awesome. Listen to this one. All right, so stay in this space in the temple and keep your eyes closed or open, however you feel, and just breathe. This is one of my favorite meditations. And if there's any technical issues, just let me know. It may unfortunately be difficult for you to. It might the
The sacred
frame
G
rate
breath
may be
is
bad,
an incredible technique
as long as you can hear
so
it,
you can
that's
function at your peak potential. In order to gain the most benefits from this technique, breathe deeply, filling your lungs up completely, and as you breathe out, ensure that there's no more breath in your lungs. You will notice partway through this technique, you start to become lightheaded. You might even get lost, which is perfectly fine. That's a part of it. After we complete these 13 breaths, it will take approximately 2 minutes for your body to come back, and you'll find that you're in a nice space of balance, peace, and focus. So let's get started. First breath, breathing in through your mouth, and out through your mouth. Breathing in through your mouth, and out through your nose. In through your nose, and out through your nose. In through your nose, and out through your mouth. Breathing in through your mouth, and out through your mouth. Remembering deep, full breaths, breathing in through your mouth, and out through your nose.
I love this one because it tells you which way.
In through your nose,
Through your nose.
and out through your nose. In
It
through your
also
nose,
charges
and
your
out through your
ways.
mouth.
But you don't have to feel discouraged or
Breathing
anything
in through your mouth.
if you lose track or whatever.
And out through your mouth.
As long as you remain breathing.
In through your mouth, and out through your nose. Breathing in through your nose, and out through your nose. In through your nose, and out through your mouth. Breathing in through your mouth, and out through your mouth. Good. Just allow yourself to rest for a couple minutes. Do any breath that comes natural. Allowing your body to come back into a place of balance and calmness. Relax and enjoy as the galactic mantra will fill your brain and your body with positive I am statements. And be sure to focus into the sacred geometry on your screen in order to create the deepest, most powerful effect.
I am light, I am infinite, I am the channel, I am expanding, I am psychedelic, I am vibration, I am timeless, I am unity, I am activating, I am resonant, I am galactic, I am radiant, I am defined, I am electric, I am lunar, I am magnetic, I am planetary, I am balanced, I am organized, I am connected, I am inspired, I am in harmony, I am integrity, I am perfect, I am manifestation, I am dissolving, I am releasing, I am liberated, I am dedicated, I am universalized, enduring, and transcending mantra. I am birthing, I am being, I am communicating, I am spirit, I am breathing, I am cosmic, I am essence, I am power, I am action, I am dreaming, I am abundance, I am intuition, I am God, I am extreme, I am internal and external, I am flowering, I am clocking, I am aware, I am life force, I am surviving, I am DMT, I am spiraling, I am art, I am accomplishing, I am healing, I am beauty, I am elegance, I am pure, I am flowing, I am love, I am chakras, I am coinciding, I am playing, I am magic, I am elusive, I am free will, I am wise, I am exploring, I am space and time, I am waking life, I am vivid, I am enchanting, I am timelessness, incomplete, infinite design, I am alien, I am human, I am receptive, I am vision, I am energy, I am mindful, I am questioning, I am answering, I am intelligent, I am fearless, I am evolving, I am opening my third eye to the unseen vision, translating, I am synchronicity, I am reflecting, I am endlessness, I am order and chaos, I am the Tao, I am crystallized, I am self-generation, I am affirming, I am enlightened, I am life, I am a tone, I am a color, I am electronic, I am lunar and solar, opposite and polar, language, I am radial, I am particles of plasma, I am endurance, I am cosmic, I am releasing, I am liberating, I am perfect, I am pulsing, I am realizing, I am the one because the one are all, I am form, I am the infinite nothing that becomes the everything, I am symbolic, I am relative, I am the divine spirit that harmonizes with the laws, projecting the digital loom, the tool of experiencing the desire and finding ecstasy in process, I am me, we are you.
watch the video on light now, or do you want to keep meditating for a little bit?
No, we need to watch the video on waves. Let's pull out of the present
Yeah, let's
and
pull-
watch something
Alright,
good.
We're out of the meditation. We've meditated, and now we can focus.
Waves have in common. Consider
Here,
a wave.
Let's start it over.
Light is a wave of electric and magnetic fields.
It's just oscillations.
Sound is a wave of air pressure. According to quantum mechanics, all the particles in the universe have the properties of waves, including all the particles that we ourselves are made from.
And the reason that I said before about the toroidal sort of field is a toroidal wave structure is what I believe to be the
Therefore,
harmonious,
to understand light, sound,
wave,
and the very nature of reality,
to attune to
it
a
is
flow.
necessary
Correct.
to first understand
Correct.
waves.
Not always necessarily a torus specifically, but toroidal waves and fields of love in nature.
There's no differences.
Exactly. Well, there are, but they're all the same.
To
ultimately.
understand the properties that all
Because
waves have in
if there
common,
were no
consider a
complex,
wave
you know,
traveling along a
The
rope.
differences, they're all the same, but the differences are the discrete parts that make the wave the thing. Without the discrete
Wanna hear-
pieces that are one, the wave, yeah. Go ahead.
Time is measured in differences.
Yeah, it's measured in duration, in cycles.
Oh, no. Time is measured in difference.
Difference between what? Like differences in
Anything.
subtraction? Yeah.
Anything.
Yeah, it's all
Your-
duality. It's duality.
Your consciousness of difference is how you experience time. That's what time is. It's your sense of difference.
Exactly, yeah.
Time is your sense of difference.
It's
Space is your sense of similarity.
Yeah, space and time are the same thing. They're it's all
Oh,
your-
they're not. No,
Well,
they're not.
space-time.
They're not the same thing.
No, they're not. You're right. But space-time is one thing made of the two of them, which is
Correct.
true. Yeah, and they're different. They're different parts that make up the whole.
He's got nice ass.
Yeah, I was gonna say abs too. He's
The
very,
wave transmits energy
thing
Yeah, he's
and
ripped.
can encode
Yeah.
information.
That's us, bro. We're fucking ripped. Oh, I'm betting
Cool.
you can't see it, but I'm banging my chest. Ooh.
Oh, I can see it in my mind's
The
eye.
atom
Yeah,
stays
exactly.
pretty
And
much
see
in the
yourself
same spot.
As in perfect physical condition. We're peak. A
You
master
have no
life.
right to tell me how to see myself. Listen to me, man. You have no fucking right to tell me how to see
You're
myself.
Absolutely right. I take it back.
Thank you. I appreciate that, and I love you.
I love you too.
I know.
And I know you know.
You? How do you know?
Because you've told me. However, you
You shouldn't
could,
trust me at my.
That's true. You could be.
Oh, you
lying.
shouldn't trust me, bro.
But I can
Could be.
I can feel it sometimes.
When a wave reaches the end
There
of
you
the
go.
rope, the wave and its energy are reflected back.
But know that I love you no matter what.
I already do know.
I'm glad you do.
No, I've known since before I met you.
You did, I bet. Yeah.
You should take bets on that. Leave it to the archaeologists to figure it out.
If the end of the rope is
That's so cool.
fixed and can't move,
Thanks you.
the
too.
reflected wave is flipped upside down.
Whoa, the reflected wave is flipped upside down.
Yeah,
Look
isn't
at
that
this.
interesting?
Whoa. Whoa.
Yeah,
Look at how it just did that.
Yeah. It becomes,
Just flipped.
Yeah, it bounces off. It rotates 90 degrees. Isn't that
It
interesting?
inverts.
Two waves
it
It's an
collide.
inversion.
They pass right through each other.
Oh, I've never seen that before.
That's so cool. Good choice.
Whoa, what's this gonna do?
You'll see.
What do you think they're gonna do?
When the two waves are on top of each other, they can momentarily cancel each other out.
But then they continue. They go on.
Pass through each other like it's nothing.
Yeah.
They're like ghosts.
They disappear for a
Waves
minute.
are just like ghosts.
Yeah.
Particles are the bodies
When the
that
two waves
ghosts
are on top
inhabit.
of each other, they can also momentarily strengthen one another.
Yeah.
Oh yeah, whip it up. Slap in the air.
Yep. They increase.
Love that.
And then they continue going.
Bounced off each other.
Yeah.
Or did they bounce off each other, or did they just pass through each other?
I think they just pass through each other. They combined and then
Right.
pass through. Yep.
Because when they bounce
Actually,
off,
the
they
two waves
hurt.
strengthen.
What's interesting is functionally, it doesn't even make a difference. Even if they did bounce off, it doesn't matter. It could be, it's both.
each
It's a-
other
it's a
where they
superposition.
intersect.
Yeah.
It's both and neither.
Now
Yeah.
suppose we have more than two waves.
This is an excellent decision. Nice choice.
Thank you. I'm glad you like it.
I've seen it before too. I love it. I love watching videos more than once too. It's good to, especially educational ones. You need to watch them more than once.
Now suppose we have an infinite number of waves.
I love the rock music.
This
Can you
guitar.
hear that?
Yeah, dude.
Yeah.
Yeah, the guitar is killer.
Like, damn.
Riff
yeah.
it. Riffing.
Mhm.
Damn. I wish I had an electric guitar. I'd be like, "Meh."
Yeah.
This wave is
actually
composed of
have
an
one, but
infinite
I've
number of
never really
waves
played it.
that spread out in all
I
directions.
have ADD, so I wasn't able to focus, and I was too up there. I have a different purpose. Maybe later in life. So these waves are
That's true.
starting, and they're about to collide and go past to each other and everything. I love simulations. It's so amazing.
Too.
When added together, they form a wave that travels in
I was
just one
expecting
direction.
them to like create like ripples, but they actually
Right?
combine.
Wouldn't you expect that?
Yeah.
They cancel out into one big wave front. Yeah.
They combine.
Let's
into
consider what
straight-
happens when this
That's
wave
crazy.
hits a barrier with a small hole.
Oh, what?
That's when.
At the edge of my seat.
Yeah, right. Oh, especially with the music too. It's like this is physics,
Yeah.
bro.
The waves behind the barrier are
Yeah.
blocked.
Well, physics.
It's very exciting to me.
Yeah. And that's how
On
it
the
should
presentation, right?
Be. Oh, I can't wait
Yeah.
till education is like this, like normally.
Only the wave behind the hole passes through.
The rest would bounce off and eventually dissipate. Although if there's no friction, they would just bounce off and go on forever.
Since this wave no longer has the other waves to combine with, there is now nothing stopping it from spreading out in all directions.
Now, what's
This is the
interesting
reason-
is these are coming out not in a straight wave like it was before. These are coming out in a pulse, sort of like a round wave. However, I feel like, if I'm not mistaken based on this, even if it was the combined waves of all the other waves from before and it passed through, the
Why
result would
waves
still
spread
be
out when
exactly
they
the
pass
same,
through
that
a
it would
small
end up
hole?
looking like that. It would turn into a circular wave. Or a semicircular wave.
Wait.
Like, I feel like it does, even though, see how these waves are obviously like half circles? And then the waves that are generating them are also circular too, but much larger. If I'm not mistaken, if this was not the same pulse wave, but the combined wave that was a straight line from before, here, this, let me, all the way, when these ones were combined, this one. I feel like if this one hit that wall, like basically like it almost does here, I feel like the result would still be the same, and it would still come out like that. However, that's just my hypothesis. Does that make sense? Yeah? Okay. I wasn't
Now
sure.
suppose the hole is bigger.
Ooh. Oh, look at that. It breaks apart.
If the hole is bigger, then more of the waves are able to pass through.
Huh. And then it creates the instead of the wall, the
If the hole is small, the wave spreads out in all
It's
directions.
so crazy too, because you can imagine this. You can see how it applies to light too. Like, I think later on in the video, especially.
If the hole is bigger, most of the
Yeah,
wave keeps
like-
moving
like,
forward
I
without
feel like-
spreading out.
Doesn't that look like light, almost like a flashlight, like shining out, like the one in the middle?
I
It's got-
said you're right. I
Yeah.
said you're right.
Yeah. I'm sorry, I didn't hear you.
To understand
Oh, I'm
why
sorry.
this happens,
No, it was just
consider
just
the
audio.
pattern that forms when a wave passes through a large hole. The waves going to the sides often cancel each other out, whereas the portion of the waves going forward always strengthen each other.
Yeah. But they also at the same time spread out. Of course, this isn't a perfect, frictionless environment with unlimited energy.
However, if the distance between the incoming wave peaks is much larger than the length of the hole, then the waves that pass through the hole strengthen each other in all directions.
If the distance between the incoming wave peaks is much larger than the length of the hole, then the waves that pass through the hole strengthen each other in all directions. Huh. Ah, yeah, see how they sort of, they sort of become straight here. And it just keeps expanding.
The wave spreads out when the distance between the wave peaks is much larger than the length of the hole.
Yeah, when the distance between the wave peaks is much larger than the length of the hole is when they spread out.
All has to do with the ratio.
Yep. The ratio of the size of the hole, the wave, the strength, the amplitude, all that stuff. And probably.
If the distance between the
oh
wave
my god,
peaks
this is one of those times when I was watching this video and I was like, oh my god, that looks just like a flashlight. Like that looks just like a light.
Oh.
is much smaller than the length of
so
the
helpful.
hole, then the wave moves forward without spreading out.
Visual aids are undeniably, incalculably, infinitely helpful in these situations.
Unmatched.
Moment of silence for those who cannot see. And hope
For
that the
this
world
same
can
reason,
fix that
if the distance between the wave
create a help for them, an accommodation for them.
wave peaks is much smaller than the size of an object, the object will
Now, this is interesting because I feel like in the real world, wouldn't the waves wrap around, kind of? Like, wouldn't it create a sort of a chaotic, or a sort of turbulent flow? But
block the
perhaps
waves.
not, depending on how they are. Because I feel like these
An
waves
interference pattern.
spread out beneath each other. But these are waves that are straight.
But
these aren't
if the
curved
distance
waves.
between the wave peaks is much larger than the size of an object, the waves
Oh, yeah,
will go
then they
around
do
the
go
object.
around. Yeah, that's okay. So it's all the size.
It has to do with the ratio.
Yep.
Ratio.
The ratio of the peaks to the object or the hole.
In the case of
Yes.
sound waves, the distance between the wave peaks is much larger than most objects we deal with.
And it goes through a lot of stuff too. Except for those special soundproof things that are designed to catch the waves and bounce them into,
Sound
into
waves
nothing.
can therefore go around most objects.
Into heat.
Yeah, into
Into
heat.
nothing,
Transfer
into
them to
heat.
Yeah, pretty much. Yeah, just radiation, but heat radiation.
In the case of light waves, the distance between the wave peaks is much smaller
Actually, literally infrared light, turning it into light, turning
than
sound
most
into light.
objects we deal with.
Yes.
Most objects therefore block the passage of light waves.
Yeah, because they're so small. And that also, that explains why, how I was saying it would, because the waves before looked like water with the ball in it, and when they were small, and I would think that they would wrap around, but they were just too small. And it makes sense because, if you shine light at a wall that's, polarized and straight, it's just going to have a shadow where the light, gets blocked.
Yeah.
Physics, the universe. This is like biology. This is like learning about yourself on like a universal level.
Well,
This
metaphors.
is the reason
Yeah.
why we can hear things even if there is an obstacle in the way. But we can't see things if there is an obstacle in the way.
Unless, of course, the obstacle is transparent to that wavelength.
Some materials allow light waves to pass through.
As I was saying, yeah. I love Eugene. Eugene is
Although
so
the
good.
speed of light through empty space is the same to all observers,
And whoever the voiceover person is.
light slows down when it passes through certain materials. The image is distorted because when a wave passes into a material where its speed is different, it changes direction.
That's so crazy. That means that what's wild to me is that applies to our thoughts and emotions too. When they, go out and they hit substances and stuff, they bounce out like waves and things like that. It's so crazy. Because the whole universe
To understand why
is
waves
just waves, vibration, toroidal
change
fields.
direction when they enter a material where their speed changes, consider the following. If a wave enters the new material at a 90-degree angle, then it will continue moving in the same direction as before.
Just slower.
If the wave enters at a different angle, then the left side of the wave will enter the material at a different time than the right side.
Thus changing the direction. The car analogy is so good.
White light is composed of all the different colors combined together. Each color of light is an electromagnetic wave with a slightly different frequency. In some materials, the speed of the wave does not depend on the wave's frequency.
Just slows
In
it
other
down more.
materials, the speed of the wave does depend on the wave's frequency.
It's kind of funny that I guess that is kind of a Porsche-looking sports car, but you'd think that the you'd think that the higher frequency colors would be the faster cars. You got the sports car all the way down in the orange spectrum, moving faster than the Mini in the blue spectrum, or moving slower rather. It's just funny that to make the analogy more like intuitive, the higher the frequency, the vibration would be a faster, is a faster, movement. So you'd think that the faster cars would be the ones moving faster. But it's just funny.
Oh, light travels at the same speed no matter what frequency it's vibrating.
Yeah, no, I know. But when it enters what she's talking about is when it enters a prism or something like that changes the speed of the different
It's the
frequencies.
medium.
Yeah,
The
the medium.
dispersion. The dispersion. Yeah. There's a dispersion relation.
Yeah.
That's the
What I
term.
was saying is that the higher wavelengths you'd think would be the sports cars, and the lower wavelengths would be the regular cars.
If white light enters this type of material, each color will bend at a different angle, causing the colors to separate in different directions. This is why sunlight passing into rain droplets can create a rainbow. Consider a case where the speed in the material we are entering is significantly faster than in the material we are leaving.
In that case, we'll turn back.
If the angle is shallow enough, there will be a total reflection of the wave.
That's how mirrors work. It's interesting.
This is how light stays inside fiber optic cables. Although waves sometimes reflect completely, there is always at least some reflection every time a wave transitions into a material where the speed is different. The greater the difference of the speed in the two materials.
I like how the background, like the planet, it's like upside down. Like the planet.
Too.
Yeah, that's cool, isn't it?
Materials, the greater the reflection.
Oh, they flipped it over.
If the material we are entering has a lower speed than the material we are leaving, the reflected wave is flipped upside down.
Just like when it was blocked. That's interesting. Did you see that? If the material that the light is entering has a lower speed when that the light is leaving, the reflected wave is flipped, like when it's blocked. Like remember when it hit the wall and it flipped upside down? Some of the energy goes through that way, but the rest of the energy here, I'll show you.
Wave is flipped upside down. In the material we are leaving, the reflected wave is flipped upside down.
It's cool.
Interesting.
Yeah, makes
Pretty
sense
cool.
because it's denser and therefore the obviously the density is what determines whether it reflects or not.
Right.
Yeah.
Well, not just
We
not
have
not
more
the
than-
density, but the
Yeah.
ratio.
Yeah, the
the
ratio.
ratio of densities.
Yeah, exactly. Yeah, that's what I meant.
One
Density
boundary.
density is just an
Then there will be
average.
Yeah, yeah. It's all about context and ratio.
a separate reflection at each boundary.
Ooh. So this one's gonna go. This one on the left here is gonna hit it. It's gonna go through, and it's gonna go upside down, and then this one's gonna keep going.
In the case of light waves, these types of double reflections occur at the surface of air bubbles and on thin films of oil floating on water.
Huh.
The two reflected waves can either strengthen each other or cancel each other out, depending on the frequency of the light and the distance between the two boundaries. Since the thickness of the bubble's surface varies from one spot to another, different spots on the bubble will have different frequencies of light strengthen each other or cancel each other out.
Oh, I love physics.
Dude, it's my favorite.
This is why bubbles and thin films of oil sometimes have a rainbow appearance. If a wave is fixed at 2 points, it can vibrate like this.
Like a guitar string.
Yes. Love instruments
If it has
and
more
apparatuses.
energy, it can instead vibrate like this.
Tools.
You know, a lot of physicists are also really good. They enjoy music too. They like being musicians because they understand the concept of waves and vibrations. So they actually can get really good at it. It's pretty cool.
Interesting.
With even more energy, it can vibrate like
Not
this.
all of them, obviously, but a surprising portion of them.
Or like this.
It's like a jump rope.
According to quantum mechanics, all particles are described by waves. The wave describes the probability of where the particle is located.
I like how it makes
If
sense
the particle
because
is giv-
since it's bouncing back and forth, it spends most of its time in the middle. So at any
Exactly.
Yep.
Exactly.
Yep.
You
so
got it.
At any given time, it would it's most likely to.
Even more energy,
Yeah.
the wave will look like this.
Ooh.
Oh.
Yeah. Because it's moving faster.
As the particle loses energy
so
to
happy.
the surroundings,
Yeah.
the wave
Me
changes.
too. I'm very content.
Me too.
The probability of a particle being at a particular location depends on the wave's amplitude at that location. This means that in this case,
I just want to pause and be so grateful that it actually this worked out so well. Like our streaming, you can even hear the music too in the background. Oh, it's getting so much.
Yeah.
the particle has a zero
We're learning.
probability of being in the middle area where the wave's amplitude is 0. The particle somehow transitions from one side of the box to the other, without ever crossing the boundary in between.
Just teleports. It's vibrating. That is crazy, yeah. Probability is 0. Even though
This means
upon, with enough, quantum entanglement, eventually it breaks down.
that this is not an accurate representation of how the particle is moving, and there is no accurate representation. Let's try to represent the particle moving in a different direction. As before, how the wave looks depends on the particle's energy.
Vibes.
Vibes.
Vibes and
Now
energy.
let's try to represent the particle moving in both
Yeah.
directions.
Okay, so it's a combination of both directions.
Yeah, now it's bouncing along the walls. And it has a chaos.
Whoa!
Yeah.
The
Whoa!
wave describing the particle now oscillates in both dimensions.
It's pretty wild.
Yeah.
It's interesting how many places that there are 0 probability of the particle being, though.
Yeah, they're called nodal points. Those are my favorite points. You know what they also remind me of?
What?
How the wave
Remind me of when in orbit, Lagrange
Oh,
points.
look, yeah, that makes sense. The
Looks
points
depends on how much energy the particle has in each direction.
Gravity.
stability. Yeah, gravitational stability.
Called equilibria. Equilibrium points in
Yeah.
economics and game
Now
theory.
suppose that instead of moving in 2 dimensions,
Cool.
the particle is moving in all 3 dimensions.
Uh-oh.
Oh shoot! Shoot! Shoot!
And instead of being bound inside a square box,
Yeah.
it is bound by the charge of the nucleus of an atom.
Oh my gosh, I gotta show you this video real quick after this one.
Oh, I know you do.
Yeah.
Show me, baby.
As before,
Show me.
there are a number of
Show me
possible
what you
ways to
got.
describe the
Show me
probability
what
of
you
the particles.
got.
Show me what you got, yeah. I don't think I've seen Rick and Morty since season 2.
Oh, bro, I need to see the new season still.
Yeah.
Two new seasons.
These possible
Yeah.
waves are what we call the
show.
electron orbitals of an atom.
Areas of
Each orbital corresponds to a specific amount of
sped it
energy
up a
for the
little bit.
particle.
I'm so glad that Eugene put like actual subtitles in.
All the atoms and particles in the universe behave
Two.
this way, including all the atoms that we ourselves are made of.
And breath and thought.
Waves are at the very heart of the
Everything.
nature of reality.
Oh, narration by Kira Vincent. ADR recording.
He's awesome.
Actually, all right. Let's see. Let's see.
Nice.
Physics. I think it's them. Yeah, this is an awesome video.
Thanks to Google for sponsoring a portion of this video, for supporting small businesses, and for helping people find jobs. More about all that at the end.
So
Atomic orbitals have long been
they made a great more accurate simulation of what electron orbitals actually look like.
a source of frustration for me. On the one hand, you have simple cartoon diagrams that make them feel friendly, but which are so varied and vague they don't really convey much beyond the basic idea that atoms have a nucleus and some electrons. Some people try to take the cartoony diagrams and make them feel more random or quantum, which is an improvement, but they're still very much just cartoon stand-ins for the vague idea of atom. On the other hand, you have atomic orbitals depicted as fuzzy clouds.
I love these because they show how they're all toroidal in nature. How all the orbitals are toroidal.
Clouds or balloons or rainbow donuts, which are definitely more technically accurate or technically inspired, but none of which feel like they give me a sense of what's actually going on. Like, what does this blobby thing have to do with orbiting electrons? Is the electron inside it or on the surface? Why do some of them have blobs and others donuts? And why are some of the donuts rainbow colored? I want to know what an atom looks like, and I want that picture to actually have something to do with the nitty-gritty reality of atoms, since they are indeed
Love
real
minute
things.
physics, dude.
You know, like how a
Highly
diagram of the
recommend
solar
this
system
channel.
is both a totally not-to-scale caricature, and yet also represents the very real idea that the planets all orbit the sun in roughly the same plane, and that some are farther out and some are closer in, and if it's animated, we get to see that the closer planets complete their orbits more often. It's a nice picture, and that's what I want for atoms. A good picture. There are a few things I'd like that picture to get across, some of them because they're important for the physics of atoms, and some of them because they're questions my brain wants answers to. Like, where is the electron? How fast is it going? How much energy does it have? How big is this picture relative to other pictures? Of course, the wave-particle nature of quantum mechanics means some of these ideas, like the electron's position, don't translate exactly from our everyday intuition to the atomic scale. But there is a way of thinking about wave-particle duality where you picture the wave function as a bunch of water, and the particle as a speck of dust in that water. The particle is mostly guided by where the water goes, and the water is guided by the equations that determine how water behaves depending on its circumstances. And if you apply the mathematics of that idea to atomic orbitals, and then render it in 3 dimensions, here's what you get.
Here you go.
Isn't that sick?
More realistic, huh?
Isn't it beautiful? Here's another. And another.
They're so
And another.
awesome. They're just clouds.
In fact, I made a bunch of these, and they're all mesmerizing and beautiful, and isn't the ground state of the hydrogen atom just so cute? And aren't the excited states so majestic? There's so much structure and detail in them, I just love it. you can
It's
see
all based on sacred geometry.
patterns in the orbitals, and you can get a sense
Or
that
at
they
least
actually
rather,
are
sacred geometry is all based on this stuff.
orbitals. I mean, something is orbiting.
Right.
Okay, so I do have to be clear. The dots don't each represent a separate electron. The whole collection represents the wave function of a single electron, and the individual
One
dots represent all the
electron.
places that electron could be. A higher density of dots means a higher probability of the electron being there. The bigger orbitals are the ones with higher energies, because electrons with more energy are more likely to be far away from the nucleus. The motion of the dots is showing the flow of the wave function, and does correspond to an extent with its actual angular momentum, though they're not electron trajectories. Unless you think Bohmian trajectories are real, in which case they really are electron trajectories. I'll let the philosophers of physics fight that one out. But the point is, these visuals are created by representing actual electron wave functions in a visual language that
I've been
minds can
thinking about
understand.
Bohm
That
this whole time.
Yeah.
So I'm really ready to. Can we talk about that real quick? Can we
yeah.
talk about David Bohm?
Here, yeah.
and
let me
light and
just
shadows and motion in
make
3D
sure this
space.
is, like, over.
There's actually stuff orbiting, and they're pretty.
Well,
Yeah,
what we'll do after this? No. Let's watch it. But afterward, let's watch a Bohm video
Yeah.
from the Bohm Society.
Sounds good.
Hope you like them as much as I do. Oh, one final thing. I 100% get that these are not easy to draw. So if you want a cartoon representation of an atom that's simple but more closely based in atomic physics, here's my proposal. It's based on the orbitals from the p block of the periodic table. One of them has the electron orbiting one way, one in the opposite way, and in the third one the electron is orbiting the same amount, but around some perpendicular direction, and we can't know which is why the dots aren't moving in the middle orbital, and why I've drawn a dotted line and question mark for the sideways circle. And if you want, you can add an electron to each orbital, or 2 electrons, one oriented spin up and one spin down. This is a Minute Physics approved cartoon representation of an atom. But really, the beautiful 3D ones are where my heart is.
Definitely. All right, yeah.
Thanks
we
to Google
said,
for sponsoring this.
Bohm. How do you spell that? Do you know? Is it B-O-H?
Yes, BOHM. Yes.
Bohm. Should we do Bohmian trajectories or Bohmian mechanics?
No. Type in Bohm Society.
Bohm Society. Okay.
Go to that channel.
All right.
Choose whichever one you want.
Oh yeah, you're right. You showed me these. Let's see.
I have to watch all of it. You can literally choose any one you like and then skip to a random part because every fucking thing that guy says was golden. David Bohm was literally just.
I like this one. I want to watch this one because it's kind of short and it's about the ego, and about how the ego
Yeah.
can cause problems. But I also want to disagree with some of it because the ego is important, but only in very small, discrete amounts.
You don't even know, bro. You don't even know yet.
Yeah, exactly.
You will know.
Yeah, we'll see.
Only know because you will.
If you're not stuck in a rigid assumption,
You will.
then your mind is
Your will.
free to move wherever it needs to move, right?
If you're living in a particular culture and everyone shares the same assumptions, how do you know that they're assumptions?
Well,
You
that's
can
the
hear
question.
it
You
well,
see,
right?
like, take Newton. There already was evidence,
Yes.
you see, that these assumptions were false, right? But the mind has a sort of a rigidity, so it doesn't. It puts that in one compartment, the evidence of the falseness of the assumptions, right, of physics, and in the other compartment, it just goes on with its old habit. You see, so there are 2 compartments in the mind. You see, that's the way people were working. Right? They were not allowing. There was concealment because one compartment was not allowed to know what was in the other compartment.
Are there any tricks that we can use to find out what our assumptions are? And
Well, I think the other way around. We have to discover the tricks by which we fail to see what our assumptions are. It's through tricks that we fail to see this.
What tricks do we use?
Well, we must discover them, you see, but there are obviously tricks. You see, somehow there must be a trick which allows a certain fact to be in one compartment, a related fact to be in another, and they never meet.
I was proposing that maybe that could be one of our questions. Is what tricks?
Yeah, what are our tricks to prevent the seeing of assumptions?
It would seem that our daily life is connected with that, at the points of challenges and points of tension that come up every day. But I think this is where people are hooked on the assumptions, and unless one yields to those points of tensions and conflicts, nothing is seen.
Yes, but you see, when there is tension, then there is tricks to. You see, there should have been tension in scientists' minds when they said heavenly matter and earthly matter are different, and also, but they are not different, right? That should have produced a state of tension, a healthy tension, right? But it didn't. You see, that was part of the trick, how you get rid of tension, which you ought to have, right?
Oh, I didn't mean I meant challenge.
Yeah, but that was a challenge.
Here, actually, I'm gonna look at this one.
We touched a lot on quantum mechanics, and I know you have some
reservations
reservations about relativity as well. I've
Yeah.
never quite understood what they were. Maybe.
Well, it's the same question. You see, first of all, insofar as relativity takes this space-time continuum, then it implies that time is like a substance or something you move through, and I don't think that makes sense, you see. Now, there are a lot of...
Wow, this video has 97 likes and 0 dislikes. I'm gonna add to the likes.
ways in which you can see that relativity and quantum theory need to be changed together. Now, see, if we come to quantum mechanics, and I say one of the things about quantum mechanics is that there are two very elementary points that it doesn't deal with. You see, one is the existence of things. See, quantum mechanics says nothing can be discussed except what will be observed when you have a piece of equipment, the probability of that. Now, if we take the whole universe, we would have to suppose another universe of observing equipment, perhaps quite a bit bigger than the first one, before we could see what that meant. Nevertheless, we must say that in some sense this does not require that universe of equipment. It's there without it. You see, so the first step, it's something like Bohr saying the classical mechanics didn't explain that atoms are there. You see, that was the most fundamental thing, the clue to something new. Now, see, the quantum mechanics doesn't explain that matter is there without really a tremendous amount of equipment to specify its state. Now, suppose I say now that, first of all, though, coming back, the things are there without the equipment somehow. And the second point is quantum mechanics doesn't discuss the actual process. You see, if you take a radium atom, say a single radium atom decaying into a Geiger counter, with the gas in the Geiger counter, then quantum mechanics says it has a wave function, and in 2,000 years half the wave function leaks out of the atom. But in some cases, something happens immediately, and in fact, you can discover, let's say it takes 10 years to decay. So what happens is if the counter doesn't work for the first 10 years, you know that nothing has happened, that the wave function is entirely inside for the first 10 or 100 years, or whatever. Right? And that contradicts the idea of Schrödinger's equation, which says that it was leaking out all the time. You see, so something is happening whose movement is not described by Schrödinger's equation. Now, the theory says Schrödinger's equation is the most complete possible description. So I say that must be wrong. That Schrödinger's equation is an abstraction of a fragment.
But at one time you tried to look at this through the notion of hidden variables.
Well, that's one way of saying that there's more to it through hidden variables. But now, that was perhaps too classical. It was merely a way of getting insight into...
But would it be true to say that there was some misinterpretation of what you were trying to do there?
Yeah, I think people thought I was trying to return to classical concepts, but I was merely using the hidden variables to get imaginative insight into what the theory meant. So one could see that the hidden variables would have certain peculiar properties which suggested that you should look at it in another way. Now, you see, for example, one discovers that these hidden variables have the property that they imply instantaneous connection of all parts of the universe, an extreme form of wholeness, and some people have said, well, that's so strange that we don't want to consider it. Now, I don't think that makes sense, that attitude, because you say, as long as we do the computation, we can sort of, we don't imagine anything about it, so, you see, we're not disturbed by anything that happens. You see, we have all this happening, all the correlations of things far away from each other. We say it doesn't disturb us because we never mention it, we only compute. So, therefore, I don't understand the attitude which says that if we use hidden variables, they have strange properties, and therefore we would rather not use them. See, I'm saying by using hidden variables, your attention is focused on these strange properties, and you begin to see that quantum mechanics, by understanding it imaginatively, even if perhaps not in a fundamental way, you see that quantum mechanics implies something very new, which you are missing by just doing the computations.
But then the sort of traditional physicists would ask you to produce a new prediction or some new
well, I think that again is a sign of a certain attitude to physics, which says the essential point about physics is to predict something, you see. And I say, why do you want to predict? You see, people talk about prediction so much that you almost feel there's a predictive instinct that will be satisfied.
Sometimes predictions are useful, but yeah, understanding mechanics are also equally useful without necessarily predictions.
If you can predict. But obviously that's not the case. The reason why people want to predict is to confirm that their ideas are on the right track. I'm trying to say that in some cases you can't predict, and some of the things are ambiguous, you see.
But would it have been true to say that if you had, with the aid of hidden variables, predicted something, which was in contradiction to quantum mechanics, and in fact the experiment agreed with your prediction, it would have been very difficult to retain conventional quantum mechanics.
That's right, but we're confronted with a situation in which the traditional way of trying to see the weakness of a theory is inadequate. You see, the traditional scientific method is to say, wait until an experiment clearly shows you that you're wrong. But if you're going on with confused methods, no experiment will clearly show you're wrong, because you can always modify the theory, as people have done with all sorts of modifications. Now,
there's a great physics video by Eugene about that. I'll see if I can find
so I'm saying we've got to look at it differently and say there is something which the present theory does not have in it, which requires understanding. Namely, there is an individual actual event, this decay of the radioactive nucleus, which is simply not accounted for in the present theory, and we must put in new concepts to account for it and see what happens. Now, you see, I think there's a lot of confusion here, because first of all, many people don't fully and deeply realize that there is something missing. They get so used to doing statistical calculations and saying only statistics matters, that they don't notice there is an individual actual fact which is not accounted for. Now, if something is happening that's not accounted for, you want to put something into your concepts that accounts for it, you see. Now, even if you can't use it to predict anything more for the moment. I mean, now, perhaps later you will predict something, but I think there's an overemphasis on prediction and on getting results, which is stifling physics, you see. That step of Roger Bacon, which made experiment important, was so creative in that time, is now getting in the way because it is being held on too rigidly. At present, we don't want to emphasize predicting particular results too much, but rather trying to give an account and get some order into the fact, in the whole fact, you see. I feel the fact is not fully accounted for in an orderly way, and since it's confused, if we start with a confused account of the fact, we will never get a clear clue for the next step. Now, I think this confusion ties together between relativity and quantum theory. See, quantum theory does not give a clear account of the fact that atoms exist, really everything exists without too much intervention by human physicists, and that furthermore that actual processes take place, not described by Schrödinger's equation at all. Now, suppose we would begin with another account, simply to say that stationary states, the world is very nearly in a stationary state, you see, but it's with some transitions. And we say stationary states just simply exist. That's our way of talking, and they make jumps from one to the other. And we haven't explained why that happens, but we're only accounting for this fact. And therefore, then we don't need this equipment at all. We see, we're not going to interpret quantum mechanics as what an observer will see, but as a process of jumping between quasi-stationary states. Now, and then we now explain that we have what we call a material system, which comes by a stationary state of a large number of atoms, which, when you solve the many-body wave equation of quantum mechanics, you see that you cannot make this relativistic at present. You see, you need to put one common time for the whole system. Now, this material system is essential to relativity, though, because if you take the theory of relativity, it always presupposes some quasi-rigid material system, which is the frame.
Yeah, that makes sense, because in a multi-body problem, each of its own, based on the density of the bodies, they have their own time frame.
To make your observations from. You see, I don't think that from a single atom you could ever get any definite meaning to relativity. You wouldn't have a clear definition of properties such as direction, for example, and so on.
But could I ask you the sort of thing Penrose was doing, in which he tried to take collections of atoms, and he thought in that way you could define notions of direction?
I understand that's a particular approach, but I think he still accepts the rest of the quantum mechanics, which implies that there's the observer who will observe these things.
Yes.
And therefore I feel that there's no clear, unconfused account of the actual fact in front of us. You see, I want to start by saying that physics has given us some facts, but they're not clearly, the actual language of discussing these facts is confused.
Yes.
Now, he is working on some particular mathematical structure to try to do something which may well be worth doing, but I'm trying to discuss something else.
Yes.
I think something has to go on which is still a lower level, as it were.
Yes.
Now, so I'm saying we have got to consider that this piece of apparatus, this block of matter exists, you see, without any help of observers. It's in a very nearly stationary state, and it determines a frame. And when you look at relativity theory, you see that's one of the chief things that's missing, is that one sees no clear definition of a frame. See, if it were not for quantum mechanics that makes matter stable, there would be nothing in relativity that would allow for the frame that measures anything.
Yes.
So there seems to be a deep relation of relativity in quantum theory.
Yes.
Now, you can pursue this, because you also discover that if you take the stationary states in one frame and then move the system and accelerate it, the stationary states of that system are not compatible with those of the first. See, they're non-stationary, and if they correspond to operators, which we discussed before, are not compatible. So if you have one system in stationary states, then another system moving by is not in a stationary state.
This is moving uniformly.
Uniformly or non-uniformly. It's not in a stationary state, but relative to the first system, but it is relative in its own frame.
Yes.
So if there were an observer inside, he would be built out of atoms in those stationary states, then he would see everything relative to those stationary states, changing. Yes. So we now see we have an interesting conception, which is that there's a relativity of stationary states, and that what is stationary for one block of matter is not stationary for another. You see, now that concept is missing. That removes the difficulty about the fact that you give the same time to all the atoms in one system, because we say there actually is a common time which is relevant for determining the stationary states of the first particle in technical terms as the time displacement operator for that system. Another system has another time displacement operator determines another set of states. The two systems are not stationary together. Now, we can now get an extension of relativity because we've introduced a new concept, which I call the concept of the material frame, and of the natural frame for the stationary state. Now, this means, however, that Schrödinger's equation cannot be taken as a complete account anymore, because each system has its own Schrödinger's equation and its own giving its own stationary states. You see, and one should not try to say that Schrödinger's equation, a single Schrödinger's equation, covers the whole universe.
Yes.
So we say a particular material frame, a block of matter, for example, is determined by solving Schrödinger's equation for some atoms.
Yes.
And then that can be extended abstractly into the surrounding space, but then another set of atoms has its own frame, and they may be related approximately, but not exactly. You see,
yes, and how does the notion of space, is the notion of space a sort of relational?
Yes, well, space comes out as relational space and time, because you see, from this structure of atoms, we imply a certain space, you see. Now, therefore, every particular block of matter has its space, which is extended abstractly into the surrounding region, and all these different spaces interpenetrate to form what I call a multiplex. You see, there's many spaces folded together. I say, therefore, rather than thinking of space as a single substance, we can think of it as an abstract relations of the multiplex. Now, each multiplex each element of it being a fragment that is based on one piece of matter.
Yes. So it's the space we think of as three-dimensional.
Yeah.
It's really a multiplex of
many
interpenetrating
spaces. Yes. See, and that's an order that we are imposing on space and relating it to matter.
Yeah. Wow.
That's great. I love David Bohm. So insightful, man. One of the leading researchers of quantum gravity, and very he was filtered out by the scientific establishment, and his ideas were not accepted into the mainstream.
That's unfortunate.
It's not. No, it's well. It's unfortunate from one perspective, but from a more global perspective, he was ahead of his time.
Yeah.
Didn't have the consciousness yet as a culture to integrate his wisdom. So it became hidden wisdom, secret wisdom, esoteric knowledge. Exoteric and the esoteric. Oh my gosh, there's something else we got to watch. I'm sorry to be this way, but there's one more thing.
Here, yeah.
Oh,
well, how long?
Go first, then I got it. Oh no, you can go for next. I remember what I want to watch.
Okay.
Time.
Most of history.
Here, if you want to tell me, I can open up a tab for it so it's ready.
I'll just tell you when we get there.
Okay.
The word scientist did not exist in the English language, nor was there any other word that conveyed a similar meaning.
Cool, I love this. I haven't seen this one yet.
Oh yeah, this one's great.
For Eugene, I mostly focus on his technical videos, but
Even Sir Isaac Newton
this is
was never
awesome.
called a scientist during his lifetime, but instead called a natural philosopher, because the word scientist did not yet exist when Newton died in 1727. The word scientist in the English language was coined in 1834 by William Whewell. William Whewell is the same person who coined the word physicist in 1840.
Wow, I came up with scientist and
Despite their many successful contributions to science, William Whewell and Isaac Newton also each developed ideas that we today consider to be highly unscientific. From the beginning, there was considerable debate about how scientists should be different from philosophers, and about what steps should be included in what we now call the scientific method. The answers to these questions developed gradually over time. There were many various opinions, and there is still debate today. For example, quantum physics allows us to make incredibly accurate statistical predictions, but fails to give a philosophically satisfactory answer to what is actually happening. And many people now argue that this is not the job of science, as will be discussed later in this video. One key difference between the scientific method and the approach of many ancient philosophers.
He also has a video on all of the philosophical interpretations of quantum mechanics, which is cool too.
Is that science is
Very
based
cool.
on observations.
We can watch that one after yours if you want.
Many ancient philosophers believed that we should
Sure.
avoid basing knowledge
Sure.
on observations because our senses often deceive us, and even the most sophisticated measuring instruments can give erroneous results. They argued that the only true knowledge we can know with certainty is that which we can deduce rationally without any observation, such as the laws of Euclidean geometry. The problem with this argument is that in the 20th century, we discovered that the laws of Euclidean geometry actually do not describe the universe we live in, as has been demonstrated by experimental observations testing Albert Einstein's general theory of relativity. This demonstrates that even that which we think we know with absolute certainty, based entirely on rational deduction, might be proven wrong when compared to observations. We can only make a guess about how the world works, which we call a hypothesis, and then compare the predictions of this hypothesis with the actual experimental results. No matter how much experimental evidence we accumulate in support of our hypothesis, it's always still possible that the next experimental observation might prove all our ideas wrong, and we will have to start over. No answer is ever final. This, too, is very different from the way philosophy was often handled.
Do you know? You're probably aware of the WOW signal?
Yeah, that like the radio band that was like what, and then they wrote wow, they circled it and wrote wow.
Well, not a radio band. What it was? Well, it was detected I have it up on Wikipedia right now. Strong narrowband radio signal. The explanation, I think it was a cosmic ray. The best explanation we have is that it was a single particle, such high of energy. The amount of energy in this single particle exceeded our conceptions of how much energy a particle could have.
Yeah, it's just wild. Yeah. Huh.
Just one particle.
Just one.
So much energy.
And it just happened to be picked up by, was it SETI at the time, or was it something else?
It was SETI, yep.
Yeah.
Wait, it was the Big Ear Radio Telescope at Ohio State.
Yeah, that's so cool.
Of SETI, yeah. Mm-hmm. But yeah, just one particle can disrupt our entire idea, you know?
Yeah, it's the universe is always unfolding and constantly
scientific method. For example, the philosopher Aristotle was so highly respected that many scholars would continue to insist that Aristotle's teachings can't possibly be wrong, even if contrary observational evidence was presented right in front of their own eyes.
Yep, that's the problem of ego.
As a result, the teachings of Aristotle severely hindered the development of science for almost 2,000 years.
Smart guy, but
the scientific method requires open debate, and if people are not allowed to challenge the accepted authorities, then this is no longer science.
Literally.
Of course, this is not a new idea. For example, Alhazen, who lived from 965 to 1040, argued that we need to be highly skeptical of Aristotle and other authorities. Alhazen is quoted as saying, if learning the truth is the scientist's goal, then he must make himself the enemy of all that he reads. He argued that a hypothesis must be supported by experiments based on confirmable procedures or mathematics, and he made many great scientific discoveries based
Ibn al-Haytham, the fucking scientific method,
on these principles. Individuals such as Alhazen have
965 to 1040. Wow. What a dude.
Vigorously advocated and practiced all the ideals of what we now call the scientific method, centuries before the scientific revolution. Unfortunately, in the years following the scientific revolution, there are many times when the scientific community has failed to live up to the ideals of the scientific method. This point was articulated in 1962 in Thomas Kuhn's book, The Structure of Scientific Revolutions, focusing on the history of how science has actually been practiced by actual scientists. Kuhn pointed out that the scientific community often develops a set of broad basic assumptions, called a paradigm, which scientists are reluctant to admit is wrong, even when observational data contradicts it. Scientists conduct research and evaluate the validity of all new ideas within the context of this paradigm, and are unlikely to seriously consider anything which contradicts the paradigm. But the scientific community does eventually change its mind, moving from one paradigm to another, in a process that Kuhn called a paradigm shift. Therefore, Thomas Kuhn believed that the scientific community still makes progress over time, and heads in the right direction in the long run. Thomas Kuhn lived from 1922 to 1996, and his ideas about paradigm shifts were highly influential in the philosophy of science. Another person whose ideas were highly influential in the philosophy of science is Karl Popper, who lived from 1902 to 1994. Karl Popper proposed a demarcation line between science and pseudoscience, which has now been adopted by many people. To explain this idea, hypothetically suppose we see objects moving in front of us. Hypothetically suppose we propose the hypothesis that there is an invisible demon moving the objects. Is this a scientific hypothesis? Why or why not? Some people would argue that a valid scientific hypothesis can't involve the supernatural, or that a good scientific hypothesis should try to have as few arbitrary assumptions as possible.
I would definitely err on the side of as few arbitrary assumptions as possible, but definitely, it's definitely a scientific hypothesis. You just have to test it before it can become a theory.
Other people would argue that there is no official rule in the scientific method stipulating these requirements, and that any hypothesis is valid, provided that it can be tested experimentally.
Yeah, that's my main.
Suppose we test our demon hypothesis by placing various objects in the room. If one or more of the objects move by any amount, this is in agreement with our hypothesis because we say that the demon chose to move those objects. If none of the objects move, this is also in agreement with our hypothesis because we say that the demon chose not to move any of the objects.
Not falsifiable.
Notice that for this hypothesis, regardless of any possible outcome of
Can you
our
pause it?
experimental observations,
So this gets into the term, this phrase. This is a key phrase, and I hope that I hope that all of our listeners nestle it into their thought garden and cultivate this. What exactly is the power of proof and the power of experiment and testament? You know, the testament that is provided by a measuring apparatus is not truly that different from the testament offered by the specific measuring apparatus called a human. We take human testament. Wait, no, hear me out. We take human testament as indicative of a bunch of cultural ideals because that's what humans are sensitive to. We're sensitive to culture and memes and ideas and beliefs.
Yeah.
But and then we use their sense of belief to inform our sense of belief. Yet, with a measuring apparatus, we somehow place a different kind of ethos on its what it has to say. So, what is the power of? Oh man, what was the?
Well,
I can't remember the exact phrase, but the idea is there. So.
Yeah, the question. Yeah, the seed is planted.
Yeah.
Yeah.
we can never conclude
does have
that our
power.
hypothesis is wrong.
It's just it's just it's just about your form of testing apparatus, whether it be human or some form of something else.
In other words, this
Down to what you
hypothesis
find
is
convincing.
unfalsifiable. By contrast, an example of a falsifiable hypothesis is Newton's law of gravity. If we were to let go of a brick and it hypothetically fell upwards, then this could prove that Newton's theory is false. An advocate of Newton's hypothesis is prepared to conclude that their hypothesis is false if certain predictions fail to be observed. By contrast, an advocate of the demon hypothesis is never prepared to conclude that their hypothesis is false, regardless of any possible observations.
Yeah, which I find
Many people
generally the Occam's razor sort of not necessarily useful. However, unfortunately, the certain things we don't have the instruments available to test certain things.
People would argue that this is the real reason why the demon hypothesis is unscientific,
Pause
and
it
not
again.
because of prejudice against the.
Say again?
Okay, so an instrument is really it's a piece of engineering, right? It's an engineered or designed structure, which is meant to. I had a perfect phrase. An instrument. Well, yeah, it's an instrument is it's a device meant to distill information, right? like a measuring
falsify.
device?
Yeah. It's
Well, what's falsify? What does that mean?
Well, that was what she was just saying. Like.
Yeah, but I don't know what the word means. I don't know what that word means, so it's confusing to me.
Here, I'll show you.
This is false.
No, I'm not. No.
Falsifiable
Phil.
means that you can test it and then like the demon, like saying that the demon hypothesis that if the objects in the room move, if you think that it's because of a demon that moves the objects, you could say that if they moved, that the demon moved them, and then if the objects don't move, you could say that the demon didn't choose to move them. So that means it's unfalsifiable. In contrast to Newton's law of gravity, where if you let go of a brick and the brick went up in the air, that would falsify Newton's hypothesis of gravity, therefore proving it wrong.
The hypothesis is an assertion about what will happen. What will happen?
Yeah, it's like a guess. It's the prediction.
It's an assertion.
Yeah.
A prediction or a hypothesis is an assertion about what will happen.
Regardless of any possible observation, why the demon hypothesis is unscientific, and not because of prejudice against the possible existence. Unscientific argue that any possible observations. Many people would argue that this is the real reason why the demon hypothesis is unscientific, and not because of prejudice against the possible existence of demons. That is, many people would argue that the demarcation line between science and pseudoscience is falsifiability, and this is what Karl Popper proposed. There is debate about the validity of this proposal, and there is also debate on how to apply it. For example, some people insist that certain social sciences are not really science because they don't make falsifiable predictions in the way that physics and chemistry do.
Which I think is what you were trying to say, is that sometimes falsifiability is not necessarily doesn't necessarily prove anything.
Yeah. So to clarify, what I'm saying is falsification. It's not clear what falsification means. It means something different to different people. Yeah. So different people are compelled. Different people are compelled by different evidence, and that is where the necessity arises for consensus. This is what the scientific method is. The scientific method is a consensus protocol.
Yeah.
That's the term. It's a method by which we can achieve consensus, and if we don't have consensus yet, then it at least also provides the schemata, the scheme. It just provides a blueprint. It doesn't provide the ability. It suggests. Right, so it suggests how we might go about refining our hypothesis.
Precisely.
Refinement. The refinement. That's the word I want to end on.
The constant refinement. Yep. Totally agreed.
Cool.
Many people also argue that in the case of many pseudosciences, we actually have considerable observational evidence contrary to what these theories predict. Though this is a contradiction. We can't simultaneously claim that a theory is unscientific because it is unfalsifiable, while at the same time claiming that the theory has, in fact, been falsified.
Yeah, literally.
Arguably, if a theory has been proven false with observation, then this means that this was, in fact, a scientific theory. Just a bad one. Also, there is a debate about the very nature of science and its ability to describe reality. For example, as mentioned earlier, quantum physics
I really feel like you'd like this video. I'm glad I got to show you.
Gives us mathematical models which make incredibly accurate statistical predictions, but fail to explain what is actually happening.
Exactly. We need the explanatory mechanism.
There are many different philosophical interpretations of quantum mechanics, with
he has a video on too, and we can watch that later.
Radically different descriptions of the world. But many of these interpretations give identical statistical predictions for all possible observable data. If multiple theories make all the same observable predictions, then how do we decide which theory is the more accurate description of the world as it really is?
Right? Isn't that what you've been saying?
One popular philosophical idea is that we should prefer the theory with the fewest number of arbitrary assumptions, an idea known as Occam's razor, attributed to the friar William of Ockham, who lived from 1287 to 1347. Though this does not solve our dilemma. Many of the various interpretations of quantum mechanics each have approximately the same number of arbitrary assumptions. Therefore, in a situation such as this one, even Occam's razor can't help us determine which theory gives an accurate description of reality. Some people argue that asking whether or not a theory gives an accurate description of reality is not even a scientific question. They argue that the only question science can answer is whether...
Hold on.
They argue that the only question...
That some people argue asking whether or not a theory gives an accurate description of reality is not even a scientific question. You disagree?
Yeah, I disagree. Yes, it is a scientific question because we have not perfected the scientific method yet. There's still ambiguity in the scientific protocol.
Yeah.
Because we call it a method, not a protocol.
Yeah, exactly. It is
So,
a method.
For some people, they have their own scientific protocol. The protocol, the scientific protocol is what will prove that this argument from these people is incorrect, because we will actually converge upon the proper science. It's called spirit. It's the science. It's this. It's Hegelian, the phenomenology of spirit, the science of logic. Yeah. It's Hegel.
Yeah.
We have not reified Hegel yet, and we have not acknowledged the spiritual aspect of science yet. So
that explains why you like leftism so much, because you like the Hegelian, the dialectics, what inspired Marx.
Scientific question.
You're correct.
Yeah.
They argue that the only question science can answer is whether or not a theory makes accurate predictions, since this is the only criteria of the scientific method. From this point of view, the only goal of science is to make more and more precise predictions, and not to describe the world as it really is.
Which is actually not a
This is contrary to the views of many scientists throughout history, who believed that they were, in fact, providing an accurate description of the world as it really is. And this is the entire reason they became interested in science in the first place.
I probably wrote a comment.
They might respond by asking, if science is not about describing the world as it really is, then what discipline do they need to sign up for in order to try to answer this question? After all, this is what they thought science is supposed to do. Much more information is available in the video titled Philosophy of Physics, and in the video titled Quantum Physics, List of Philosophical Interpretations. Please subscribe for notifications.
I wonder if I wrote a comment. Oh, I did. I wrote, love this. Also, I've begun using hypothesis instead of theory when it matters. Yeah, because I hate when people say theory when they mean hypothesis.
Theory is much more refined. Exactly. A theory contains its own explanatory mechanism. Yeah. A hypothesis is a part of a theory, or goes into a theory, or drives the evolution of theory. Hypothesis. Hypothesis, we have to think of everything as process.
Yeah.
The next video has to be about Whitehead. Just type in Whitehead process philosophy.
Whitehead process philosophy, and then we can watch the list of philosophical interpretations.
Yeah. Find the one that you want. Being process and reality. Why Whitehead? Process metaphysics. Any of these will do. We just need the name.
Yeah. Here, let's. You like this one or Alfred North's? I'll go with this one.
Okay, hi, this is Kramer Knipe, and in today's video we will be going over Alfred North Whitehead's metaphysics. So I wanted to do a video on his metaphysics and its implications on psychedelic consciousness, but both these topics will be rather lengthy, so I'll have to make two separate videos for this. Now, Alfred North Whitehead was a mathematician and philosopher. At first he was a mathematician and actually taught/worked with Bertrand Russell. and later on he worked in the philosophy of science, eventually moving on to metaphysics due to his criticism of the scientific paradigm. In a letter he writes to Bertrand Russell, after discussing whether science aimed to be explanatory or merely descriptive, he wrote, "This further question lands me in the ocean of metaphysics, onto which my profound ignorance of that science forbids me to enter." Whitehead was very critical of the mechanistic scientific paradigm that propagated the notion that everything was non-living fundamental entities operating according to so-called fixed laws of nature. Above anything, he stressed the importance of flux and interrelatedness, and thus rejected the idea of irreducible brute matter and fixed laws of nature, as they do not account for change. So his philosophy is a process ontology as opposed to a substance ontology. And so he believed the world to be composed of processes and relations instead of fundamental entities in what we call matter. A quote-unquote object is just the sum of its relations and an evaluation to them. Object A is real for object B, and B is real for A, but the two are not entirely real independent of each other. Our mind likes to mediate the geometric fields of our perception into actual objects with enduring identity, but the truth is that there are no true meaningful distinctions between one thing and another. Everything is in a perpetual interdependent process of change. Thus, all is one. Now, in the scientific paradigm, since everything follows these eternal, unchanging laws, the future is determined and there is no novelty. The future state of things will just be the implications of previous states with external laws, and thus the future could be theoretically determinable given the means to do so. Even the uncertainty principle in quantum mechanics does not add novelty to the universe. It is still an eternal principle that merely blurs the determined possibilities. But for Whitehead, there is constant novelty in the universe. What we call the laws of nature are just observed regularities considered to be constant, but all is in flux, and regularity does not imply that they are constant. The ultimate principle of his metaphysics is creativity, and this is metaphysical creativity, not psychological creativity. Creativity is the ultimate category of reality beyond everything. It is where the many become a whole, and the whole become the many. It is the principle of constant interconnected novelty. This is the only real law of nature for Whitehead. So how does Whitehead's universe maintain novelty? Well, first, let's look at the building blocks of his universe, or more so the building processes. So Whitehead's universe is composed of processes, and the most basic process is called an actual entity, or an actual occasion. An actual entity is a single occasion of experience. Actual entities pertain a very primitive degree of experience and will. They have a very basic subjective aim. This theory that experience is a fundamental universal aspect of everything is known as pan-experientialism, and its merits are in the fact that the mental cannot arise from the non-mental, and thus experience must be fundamental to everything to account for the evolution of the mind. Now that we can look at all of reality as having aim and experience, we can see that the quote-unquote laws of nature are really the workings of a force of will striving throughout all of nature. The process that an actual entity goes through is called a concrescence. Now, what I'm about to say will not hold much meaning until I explain some of these terms, but just bear with me for now. The process of an actual entity begins with an initial subjective aim to create the actual entity, apprehension of other actual entities, a subjective aim that will make a decision, and then a satisfaction completing the process. The initial subjective aim is derived from what Whitehead called the eternal urge of desire, or quote-unquote God. Whitehead's conception of God is more pantheistic than monotheistic, and should hardly even be considered God, as this God is not omnipotent. Whitehead considered this God a necessity for his metaphysical system to provide order to the cosmos. His assertion of God was not based in faith, but for now we will move on and return to this subject. Now, after the initial subjective aim is inaugurated, The aim is then assimilated by the actual entity, becoming...
Which one are you? Are you, according to this chart, are you in the pantheism, or they're both called pantheism? But...
No.
no.
One is pantheism, one is panentheism.
Panentheism, yeah, I didn't see that, yeah.
Here, do you want me to explain? I will wait, yeah. I will tell you what I am and why, and I will use the names of them to explain why.
Perfect.
And specifically, I will start with the difference between pantheism and panentheism.
Yeah.
So pantheism, pan is the Greek root meaning all, or I think across, covering, like everything.
The God.
Well, okay, but the name, it's all in God. Panentheism is like, think of the name entheogen.
Yeah.
Entheogen is a name for a psychedelic, and it means it's also the same root as the word enthusiasm.
Yeah,
Entheos.
Tell me
it
what
means.
that means. Yeah. What is entheogen?
It means God. It means God within, or within God.
Entheos. Yeah, that makes sense. Yeah.
Yeah, when you're enthused, it's because you're being filled with God, or God is being filled with you.
Yeah. Yeah, that makes sense. Oh, that's so cool.
So, yeah, so I'm actually a pan-enthusiasticist.
And what's that? Yeah.
That's the next one. That's the one on the right of. It's on the right of the screen, but they cut it off. It's called pan-enthusiasticism.
Yeah.
And it's that all in God and God in all. It's the final completion of it.
Yeah, it's an infinite loop. Yeah, I think I used to be pantheist, but I think there might be panentheism is probably more accurate in that because I believe that there is more than just the universe. However, I think of what we refer to as God in the everyday basis is the more pantheistic definition, but the panentheism is probably is more accurate to assuming God
It just
meaning
depends.
origin, consciousness, creation, all that
Right.
exists.
It depends on what you assume. It depends on the assumptions of the person who is using the word. So the word God, in the beginning, there was the logos.
The words.
In the beginning, there was the logos, the word, the speech. Not the
Whatever
words,
be
the
like.
speech.
Yeah.
Yeah, and then
Creation came from there. It's cool. Cool stuff.
its own aim, independent of the God. Now, actual entities prehend one another. Whitehead uses the term prehension instead of perception to avoid the view of representationalism.
Yes,
This
think
is the
about
view that
apprehension.
there is a
Apprehending.
duality between our perceptual
Apprehension.
representations of objects and the objects
Comprehending.
themselves.
Comprehending.
Now, the prehension of an
Comprehending.
actual entity actually involves the ingression of that actual entity into itself. Instead of experiencing a mere representation of something, you experience the actual data being ingressed into you and changing you. This collapses the dichotomy between subject and object, and person and environment. All is connected. So because of looking at things this way, all actual entities are actually present in other actual entities, and this is called the principle of universal relativity.
What?
Now, the merging of actual entities into a new unity includes actual entities of the present environment and of the immediate past. So the present entity inherits the entirety of past experiences. Without this inheritance, causality would collapse.
I need
Although
to see you.
actual
I know you're
entities
cutie.
are affected by their...
If you want, you can pull up the stream. You can go to my channel on YouTube, pull up the stream, and just mute it.
Don't want to.
Yeah.
It's too much work.
Comprehensions, they're not
Lazy.
fully determined by them. They carry a degree of autonomy
way to
in their
be.
subjective aims.
Plus,
Now,
it'd be
the
slightly
two main types of prehension are positive and
Give me the
negative
view, though,
prehensions.
which would be nice.
A negative prehension is the exclusion of actual entities. These negative prehensions begin to form a limited perspective.
What are actual entities again? Do you mind if I go back?
Don't mind at all. Do as thou wilt.
Yeah.
The most basic process is called an actual entity or an actual occasion. An actual entity is a single occasion of experience. actual entities pertain a very primitive degree of experience and will. They have a very basic subjective aim. This theory that experience is a fundamental universal aspect of everything is known as pan-experientialism, and its merits are in the fact that the mental...
So an actual entity is something that has an internal experience?
cannot arise from the non-mental, and thus experience must be fundamental to everything to account for the evolution of the mind. Now that we can look at all of reality as having aim and experience, we can see that the quote-unquote laws of nature are really the workings of a force of will striving throughout all of nature. The process that an actual entity goes through is called a concrescence. Now, what I'm about to say will not hold much meaning until I explain some of these terms, but just bear with me for now. The process of an actual entity begins with an initial subjective aim to create the actual entity, apprehension of other actual entities, a subjective aim that will make a decision, and then a satisfaction completing the process. The initial subjective aim is derived from what Whitehead called the eternal urge of desire, or quote-unquote God. Whitehead's conception of God is more pantheistic than monotheistic, and should hardly even be considered God, as this God is not omnipotent. Whitehead considered this God a necessity for his metaphysical system to provide order to the cosmos. His assertion of God was not based in faith, but for now we will move on and return to this subject. Now, after the initial subjective aim is inaugurated, the aim is then assimilated by the actual entity, becoming its own aim independent of the God. Now, actual entities prehend one another. Whitehead uses the term prehension instead of perception to avoid the view of representationalism. This is the view that there is a duality between our perceptual representations of objects and the objects in themselves. Now, the prehension of an actual entity actually involves the ingression of that actual entity into itself. Instead of experiencing a mere representation of something, you experience the actual data being ingressed into you and changing you. This collapses the dichotomy between subject and object, and person and environment. All is connected. So because of looking at things this way, all actual entities are actually present in other actual entities, and this is called the principle of universal relativity. Now, the merging of actual entities into a new unity includes actual entities of the present environment and of the immediate past. So the present entity inherits the entirety of past experiences. Without this inheritance, causality would collapse. Although actual entities are affected by their past prehensions, they are not fully determined by them. They carry a degree of autonomy in their subjective aims. Now, the two main types of prehension are positive and negative prehensions. A negative prehension is the exclusion of actual entities. These negative prehensions begin to form a limited perspective on the universe. Now, positive prehensions are divided into two groups, physical and conceptual prehensions. Now, a physical prehension is just a normal prehension of another actual entity, but conceptual prehensions are a bit more complicated, so don't get worried about them for now. Conceptual prehensions are prehensions of something Whitehead called eternal objects. Eternal objects are a rather confusing concept at first. Whitehead defined eternal objects as pure potentialities for the future. Eternal objects do not exist in actuality, only in potentiality. They exist transcendentally, similar to the way Plato's forms exist, though they still affect actuality. So when an actual entity prehends eternal objects, it realizes the potentialities for the future, and then makes a choice based upon its subjective aim. It is this that thrusts the universe into novelty. Eternal objects are necessary for novelty. They give actual entities their degree of autonomy for making decisions by making the potential future apparent. If actual entities only operated according to their historical environment, there would be no intrinsic nature or novelty in reality whatsoever. Without eternal objects, the universe would just be in a static state, void of complexity. Whitehead's theory of prehension is rather genius, as it tackles the metaphysical issues of causality, perception, free will, and the mind-body problem. Now, the final phase of an actual entity after its birth, subjective aim, prehensions, and decisions is a satisfaction completing the process. The purpose of subjective aim is ultimately to reach an experiential intensity of satisfaction that finalizes the process. Once satisfaction is achieved, the actual entity makes the transition from a subject to a superject. Now, what this means is that it is no longer an active process of the present, but rather it is data for the future actual entities. So the past exists in the present as data affecting the present, but not fully determining the present due to the autonomous nature of actual entities. So we humans do not apprehend actual entities individually, but rather in abstracted wholes. What we call objects and what Whitehead calls nexus, essentially just abstract clusters of actual entities. Now, when a nexus shares a common characteristic throughout its members,
I'm not gonna lie, a lot of this is going way over my head. I'm trying to keep up.
Let's switch it. Let's switch it up, bro. It's your turn.
We can watch. I want
I
to
don't
watch the
mind.
rest of it. I just want to watch more later. We'll finish this up and then we'll watch that one and then I think we'll get going because I'm getting kind of tired.
Called a society. Societies are self-organizing clusters of actual entities. Examples of societies would be electrons,
But then on my own, I'm gonna look at more about this because this is very interesting to me.
atoms, molecules. Any self-organizing society pertains a degree of sentience and subjective aim that informs its members. There are societies within societies, so there's essentially a hierarchy here. Actual entities take in the bottom of the hierarchy, and at the top of the hierarchy is God. All experiences drawn into one society, one consciousness that values and conditions the order of the cosmos. Most people who criticize panpsychism, which is the view that all things have sentience, they'll say, well, how could a thermometer be conscious? Or how does the universe maintain order? Well, the thing is that what we call thermometer is not a real entity, it is rather an abstraction. The societies within the thermometer, such as the molecules, atoms, and so forth, all the way down to actual entities, are conscious. The only things that have subjective aim are actual entities and self-organizing societies of actual entities. There is a societal hierarchy of subjective aims all the way up to the ultimate society, being God, that keeps the universe in order. Higher societies affect lower societies, and vice versa. There's a mutual causation between all societies.
Societies meaning like groups or sets rather than actual like typical vernacular societies.
That keeps things in order. Now, God was necessary for Whitehead's universe. This quote-unquote God is not a typical conception of God. It is not omnipotent, it is not omnibenevolent, and it does not desire a following like the monotheistic gods do. Whitehead was highly critical of the Christian God. He did not like that its most important attribute was power, and that its highest desire was to be followed. Omnipotence is not possible in Whitehead's universe. Whitehead's God does not create nor coerce reality, but rather he maintains the order of reality by conditioning it. As I said, the inner societies affect the outer societies, and thus Whitehead's God is necessarily affected by the inner societies. He is not beyond them. For if he were to break free from their causation, as the Christian God does, he would break the chain of causality, thus collapsing the universe and ceasing to exist himself, for he is simply all experiences drawn into one cosmic consciousness. The relationship between God and the universe is analogous to the relationship between humans and their body. We humans can condition our body by, consuming something, exercising, etc., but we cannot entirely coerce the individual organs, cells, and molecules to do what we please. The universe is God's body, and he can condition it, but not coerce it. In summary, Whitehead's system necessitates God because A, all societies are sentient, and the universe itself is a society, and B, since Whitehead's metaphysics collapses the notion of laws of nature via asserting that all processes have subjective aim, there must be some ultimate process that values the order of the cosmos and conditions it. Now, there is a dual nature to this God. There is the consequent nature of God and the primordial nature of God. The consequent nature of God is what I have been talking about mostly. It is every experiential subject drawn into one cosmic process of consciousness. It is the collective consciousness that partakes in all experiences and thus values the order of them. The primordial nature is the realm of eternal objects. So if you've forgotten what eternal objects are, they are the potentialities for the future. Eternal objects are ingressed into actual entities so that they can realize the potentialities of the future and make a choice. The primordial nature of God is unconscious and transcendent. As I've mentioned, eternal objects exist outside of space and time because they are potentialities, not actualities. The primordial nature of God is not conscious because to Whitehead, consciousness, a high-grade form of experience, is the feeling of contrast between fact and potentiality. And since the primordial nature is nothing but potentiality, it cannot be conscious. So the consequent nature of God, which is the conscious nature, has access to the primordial nature, which is the infinite realm of eternal objects. And it is his job to provide the cosmos with these potentialities to keep causality running in order. The consequent nature of God alone is not enough, because without the primordial nature, the cosmos would not be aware of potentiality, and thus there would be no subjective aim in nature. The universe would be stuck in a static state. Okay, so now I will talk about how humans prehend reality, and then I will finish this off, as it is getting rather long. So, because everything contains sentience, there is no absolute distinction between the living and non-living. For Whitehead, the difference between the organic and inorganic is not a fundamental difference, but it's rather only a difference of degree. Now, what we typically call organisms in science, Whitehead calls living societies. He roughly distinguishes living societies as having a high degree of self-sufficiency and more intensive feelings adapted to a variety of experiences. Complex living societies, such as humans, prehend actual entities as abstract wholes rather than a mass plurality of process for ease of comprehension. This process is called transmutation. It eliminates detail and artificially carves reality into bits and pieces. It is necessary for our practical functioning, but is also a large cause of the errors of our substance-based ontology. The individual cells of living societies are flooded with data from their external and physiological environment, and the data is then transmuted into abstractions for ease of comprehension. The more complex living societies have an organ of central control in which the flood of data is streamlined into. In humans and other animals, it is the brain. Thus, the brain is not the producer of sentience, but rather it streamlines a mass plurality of sentience into a mode of experience that is practical for the survival of our species, but not so practical for metaphysics or what we so-called mystical experience. Though, interestingly enough, sometimes this organ of central control lapses, causing us to develop things such as multiple personality disorder, and, in theory, we could also prehend the direct experiences of other societies. Now, rewinding back to when we talked about the two main types of prehension, positive and negative prehensions, negative prehensions are the exclusions of perceptions of reality. Along with our process of transmutation, they give us our limited perspective of reality. Without transmutation or negative prehensions, we would experience the entirety of reality in its complex nature, all the way from actual entities to the consequent nature of God, and even every possible potentiality of the universe. It would be terribly overwhelming and painful. So I think I will leave the video off on this note. I wanted to talk about the implications this all has on psychedelic consciousness, but I will save that for another video. I will be talking about how altered states reached through meditation or administration of psychedelics begins to break down the function of transmutation and negative prehension, at least temporarily. Anyways, that is all for today's video, so please comment any questions you have, and I hope this video was comprehensive. Bye.
That was pretty crazy.
Pretty dense.
Yeah, I'm gonna, like I said, I'm going to look more up that on my own. But here, we can watch this.
Two particles are
the quantum physics list of philosophical interpretations by Eugene Kotoriansky and
Kotoriansky.
Thank
Yeah.
you. And then
You.
We'll say bye for now.
In this video, we attempt to present a reasonably comprehensive list of the various interpretations of quantum mechanics. We include options such as objective collapse, retrocausality, superdeterminism, cubism, many worlds, relational quantum mechanics, pilot wave, quantum logic, and a number of others. The most popular interpretation
Pilot wave is interesting.
of quantum mechanics is the Copenhagen interpretation. The Copenhagen interpretation states that nature is intrinsically probabilistic, and that particles don't have properties such as position or momentum until they are observed. The Copenhagen interpretation states that everything that can be known about a particle is summarized by a wave function. According to the Copenhagen interpretation, wave functions are just a mathematical tool for calculating the probabilities of all possible observations. And at the moment of observation, the wave function collapses to just a single outcome. One of the many problems with the Copenhagen interpretation is that it never states what exactly counts as an observation, since a wave function can describe systems of many interacting particles. We know that a wave function can interact with a detector without collapsing, due to experiments like the delayed choice quantum eraser. The Copenhagen interpretation fails to explain the following. At what point in time does the wave function collapse into just a single definite outcome? And what causes this collapse to occur? There are a number of different approaches to answering these questions. One set of approaches are objective collapse theories, which state that wave functions collapse on their own without observation. In some objective collapse theories, the wave function associated with each individual particle has a very small probability of collapsing on its own at each moment in time. If this particle is entangled with a group of particles, then the moment any one of these particles collapses, this causes the wave function for all the particles to collapse. Therefore, the larger the number of entangled particles, the greater the probability that the entire system as a whole will collapse at any moment. In other words, if the wave function for a single isolated particle is unlikely to collapse for millions of years, the wave function for any large object will likely collapse in less than a microsecond, due to the fact that large objects consist of a very large number of entangled particles.
That's crazy.
Other versions of objective collapse theories state that it's the interaction with the curvature of space-time which causes a wave function to collapse. In these theories, although an individual particle can be in a superposition of states indefinitely, this is not true for the curvature of space-time, and the greater the superposition of states for the curvature of space-time, the greater the probability that the entire system will collapse at any moment. The different types of objective collapse theories discussed here are all testable, in that they each make testable predictions for possible future experiments, and these predictions are slightly different from the predictions of traditional quantum physics. At the time of the making of this video, the technology does not yet exist to perform these experiments with the necessary precision, but this technology may exist in the very near future.
Fingers crossed.
One of the objections to both the objective collapse interpretation and to the Copenhagen interpretation is that when a wave function collapses, it must collapse everywhere simultaneously, thereby sending information faster than the speed of light.
That's true.
However, according to Einstein's theory of relativity, different observers can disagree on the simultaneity of different events. And if information can travel faster than the speed of light, it would be possible to send information backwards in time. This is the essence of the EPR paradox with spooky action at a distance, where we have two entangled particles far away from each other. In the EPR paradox, if we measure the spins of two entangled particles, with the detectors rotated relative to each other by 45 degrees, then the two particles measure opposite directions of spins approximately 85% of the time. This is a mathematical and logical impossibility if the two particles don't communicate with each other.
Only 85%.
One set of approaches to dealing with this paradox are the retrocausality interpretations of quantum mechanics. The retrocausality interpretations reject the possibility of instantaneous messages traveling faster than the speed of light, but they accept that messages travel backwards in time. The idea of messages traveling backwards in time is not necessarily that bizarre, since a positron moving forward in time can mathematically be viewed as an electron moving backwards in time. In the retrocausality interpretations, the two particles are communicating with each other not through any spooky action at a distance, but due to the fact that information is being sent both forward and backwards in time along the paths of the particles. The particles therefore know in advance whether or not there are detectors present, and what each detector will be measuring, and the particles set their initial conditions accordingly to avoid any future paradoxes. The most well-known retrocausality theory is the transactional interpretation of quantum mechanics. In the transactional interpretation, a wave function travels forward in time, and the complex conjugate of the wave function travels backwards in time.
So they meet in the middle.
The wave function traveling forward in time is what we consider to be the wave function in traditional quantum mechanics. But according to the transactional interpretation, we also need to take into consideration the wave function traveling backwards in time, as it's the transaction between these two wave functions that causes the universe to decide which path to select, independent of any observer. One of the advantages of the transactional interpretation is that it explains why the probability of finding a particle at a particular location is proportional to the square of the amplitude of the wave function at that location, whereas the Copenhagen interpretation just states this principle as an arbitrary assumption. The transactional interpretation does not make any claims about whether or not the universe is deterministic, since the wave functions traveling backwards in time can be traveling from possible futures, rather than a future that is predetermined. In addition to the transactional interpretation, there are a number of other retrocausality interpretations. Contrary to the name retrocausality, we don't actually have to worry about events from the future changing past events that have already occurred, since it's not possible to change something that is already determined. In fact, if the universe is deterministic, then it's not possible to change either the future or the past. And this brings us to the superdeterminism interpretation of quantum mechanics. As with the retrocausality interpretations, superdeterminism also resolves the EPR paradox by stating that the particles know in advance what each detector will be measuring, and that the particles set their initial conditions accordingly. But in superdeterminism, this is not because messages are being sent backwards in time, but simply because everything in the universe was already predetermined at the creation of the universe, and this information was transmitted to all the particles during the Big Bang. Let's now turn to the interpretation of quantum mechanics called cubism. Cubism is also known as quantum Bayesianism.
Cubism, not cubism.
That's quantum based.
Yeah.
Isn't that funny? I love the puns.
Yeah. The letter Q.
It's a pun, and it's funny. They're inspired by the Cubist painting movement.
Oh, really?
Like they're inspired by. Yeah, it's impressionistic, and so I can explain. So, well, I mean, they'll explain too if you want to just listen to them. I get it.
You can go first if you want.
The idea I have right now is that cubism or quantum Bayesianism, Bayesianism is a new interpretation, or what was once a heterodox interpretation of probability theory, because not even
heterodox meaning two different somethings.
In opposition to orthodoxy, so outside of the orthodoxy.
Yeah, okay, gotcha. Unorthodox would be the negative, sort of stigmatized version of it. Anyway, yeah. As you were saying, or were you done?
Sorry, there's a very pressing matter. The arc.
Do you have something going on? You need to go.
I don't need to go. I'm just in a. I'm getting offered some kind of position in a large movement.
Well,
the Church of On.
Yeah. Well, why don't you do that and tell me about it? I'm gonna play the video. Okay.
Yeah. Okay.
In cubism, the universe can be intrinsically probabilistic. But according to cubism, the probabilities calculated from quantum theory do not represent an objective probability that all observers agree on, but only our own personal subjective belief about the probability of an outcome. Every time we perform an observation, we update our personal beliefs about the probabilities of all possible future outcomes. According to cubism, there is nothing mysterious about a wave function collapsing when we perform an observation, since the wave function only represented our own personal subjective beliefs about the probabilities. Since these beliefs are subjective, different people might assign different probabilities to the same event. But there are nevertheless objective rules for the relationships between different probabilities. For example, if we think there is an 80% chance that it will rain, and that there is a 50% chance that a coin will land heads, then logically we should believe that there is a 40% chance that both events will happen together.
But they're not related.
According to cubism, these types of rules for how different probabilities relate to each other are different in quantum mechanics than they are in classical probability theory. This is why when we measure the spins of entangled particles, we get results that seem to be mathematical impossibilities from classical theory. Cubism denies the existence of an objective wave function, and the collapse of a wave function is simply viewed as us updating our beliefs about future probabilities. Let's now consider the following interpretation of quantum physics. This is the possibility that even as we perform observations, the wave function never collapses. This is often referred to as the many worlds interpretation, where every possible quantum outcome occurs in a parallel universe. This theory is completely untestable, but its supporters argue that there is no reason to assume that the wave function collapses. They say that the theory with the fewest assumptions should be the one we select, provided that it fits all the data. One of the main criticisms of the many worlds interpretation is the following. If a particle has a 61% probability of being observed in location A, and a 39% probability of being observed in location B, the many worlds interpretation needs to say that the particle is in location A in 61% of the universes, and that it's in location B in 39% of the universes. However, the many worlds interpretation can't explain why the split occurred with this particular distribution, unless we add extra assumptions to the theory. This does not necessarily make the theory wrong, but adding these extra assumptions takes away the main argument in favor of the many worlds interpretation, in that it was thought to require fewer assumptions.
Though there seems to be a lot of evidence for the many worlds theory.
Let's now turn to the pilot wave theory interpretation of quantum mechanics. Pilot wave theory is also known as Bohmian mechanics. The pilot wave theory states that the universe is completely deterministic. According to pilot wave theory, all particles always have a definite position and velocity, and the motion of these particles are guided by waves. For the pilot wave theory to work, interactions in any one location must be able to be felt everywhere instantly, thereby sending messages faster than the speed of light and violating Einstein's theory of relativity. The pilot wave theory also has far more additional problems with Einstein's theory of relativity than does traditional quantum mechanics. We now turn to the interpretation that some people prefer not to hear about in a science video. This is the view that consciousness plays an essential role.
But that is science.
This interpretation says that the wave function is still in a superposition of states after it is measured by a detector, and that the wave function collapses only when it is observed by a conscious observer.
However, yeah, I think that is a little silly. Because consciousness is everywhere.
Claiming that only conscious observers can collapse a wave function poses some new questions.
It's attention.
Who counts as a
Okay,
conscious observer?
can you pause it?
Yeah.
What were wave
Compare and contrast these two words. Attention and attenuation. What do those words mean to you?
Attention is like focus, but isn't attenuation like trying to achieve something, or like, you know, like having a goal in mind?
Trying means trying to find harmony. Attenuation is the descent toward harmony.
Oh, okay. Yeah.
functions doing before any conscious observers evolved in the universe? And why should the presence of conscious observers make a difference? Answering these questions require a fundamentally different set of metaphysical assumptions than we normally make in science. One possibility is that we live in a computer simulation, and to save computation time, the simulation does not calculate the exact properties of a particle until it becomes relevant to the observations of one of the players. Another possibility is that consciousness is not the result of electrochemical reactions in the brain, but is due to the presence of a soul not described by the known laws of physics, and the wave function collapses only when it's observed by a soul. These types of views have a number of challenges to deal with. For example, according to Einstein's theory of relativity, different observers will disagree about which of two events happened first, and different observers will therefore disagree about which of them collapsed the wave function. Also, we again have to deal with the EPR paradox involving the spins of entangled particles. One interesting approach to addressing these questions is by using another interpretation called relational quantum mechanics.
Yeah.
In the relational quantum mechanics interpretation, the observer does not need to be a conscious observer, but can be any system. The relational quantum mechanics interpretation states the following. In the same way that different observers can disagree about which of two events happened first, different observers can also disagree about whether or not a wave function has collapsed. From the perspective of one observer, another observer can be in a superposition of states. Relational quantum mechanics deals with the EPR paradox of spooky action at a distance by pointing out that no observer is able to measure the spins of both particles simultaneously. In this interpretation, from the point of view of the observer, the spin of the unobserved particle is still in a superposition of states until the observer interacts with something that has measured the spin of that particle. There are other interpretations of quantum mechanics that have other ways of dealing with the EPR paradox. In the EPR paradox, if we measure the spins of two entangled particles, with the detectors rotated relative to each other by 45 degrees, then the two particles measure opposite directions of spins approximately 85% of the time. This is a mathematical and logical impossibility if the two particles don't communicate with each other. Some interpretations of quantum mechanics deal with this problem by stating that the rules of logic we're familiar with simply do not apply to the quantum world. The argument is that rather than use the rules of logic we are familiar with, we instead have to use quantum logic.
Yeah, I have to create a whole new set.
In some versions of quantum logic, the probability of the truth of a statement can be represented geometrically using the projection of vectors, thereby giving us the experimental results we observe. The classical logic we are familiar with could just be a special case of quantum logic, just as Euclidean geometry is a special case of non-Euclidean geometry. The argument is that quantum logic and non-Euclidean geometry are contrary to our intuition, only because our ancestors never previously encountered them anywhere in our evolutionary history. Our brains are hardwired to think that the universe operates according to classical logic and according to Euclidean geometry, only because that is what helped our ancestors survive. However, rejecting the known laws of logic is a very big step, and we have to think very carefully before making this leap, especially since we have many other interpretations of quantum mechanics to choose from. In this video, we have tried to provide a reasonably comprehensive list of different types of interpretations of quantum mechanics. However, it's not possible to provide a completely comprehensive list, and we offer our apologies if your favorite interpretation was not listed here. Detailed information about the actual physics of quantum mechanics, as well as the philosophical nature of the paradoxes, are available in the other videos on this channel. Please subscribe for notifications when new videos are ready. And if you're able to, please consider supporting us on Patreon through the link in the video description. Thank you.
Alrighty, man. This has been fun. I'm getting kind of tired.
Yeah, man. Sorry, I got distracted. I have to partition my time to find a place to live. So
yeah, you've got you know other things going on. Yeah. So I mean, how's everything going with that? We can stop recording if you want, or we can keep going.
No, it's fine. This is fine. No, it's going fine. I'm getting people offering help and wanting to connect. So, I trust everything. I'm not worried. I just am. I need to, it's demanding my attention.
Of course.
To attenuate me.
Yeah.
Yeah.
What was the thing you got offered to be part of a society or something?
This guy from who claims at least to be part of the Church of On, which is Church of On. A-N. Church of On. A-N. Probably. It sounds like that.
Although it might have an H in it. Church of On. Maybe A-H-N.
I don't know. He has a website. Oh, here it's there's an Instagram page, Church of On. Okay. I don't know what their deal is. It might, I'm not sure.
I hope they're not a scam or something. Alright. Let's see. Let me check them out on. Instagram as soon as it loads. Is it just, how is it spelled? Is it one word, or there are underscores?
It's just one person. It appears to be his own brand.
Yeah, but like,
Church of On.
how is it spelled? Like, is it one word? Is
N.
Is it no? But is it
It's
church underscore?
different words.
Okay, yeah, church underscore of underscore on. I still don't see it. You see what I'm seeing?
Here. I'll send you their website. It looks like they're involved into NFTs. I know that that's something that you are not in favor of. I've done a lot of research, and now I have nuance, so I'm not worried about your opinion on it. But
yeah, no, that's fine.
I'll send you the link.
Yeah, send it.
There you go.
Yeah, all right, let's see.
He's involved. He's very involved. I think that he's interested in subverting global control structure using the influence that he's acquired. So
good. I just
that's what he's
feel
saying.
like, unfortunately, and I'm down with that. I just feel like the use of NFTs in particular to do that, and cryptocurrencies, the blockchain, I'm not too upset about. I don't have a problem with that unnecessarily, but cryptocurrencies, you know, by nature of being fluctuating, and the environmental impact and just capitalistic thing of NFTs, I think that they're a little meh. But yeah, no, I just think that it just generally they subvert the order by getting rid of the government and replacing it with corporations, which is just not helpful.
I mean, you can't be so be so reductionistic with it. It's very nuanced, and until you go into the spaces and connect with the people that are actually involved in it, you're not close enough to make the judgment. Or you can make the judgment, it's just not going to be very reflective or carry any weight.
Yeah, very true.
Because I went into the space with the exact mindset you have, because I watched the same video you watched. I was skeptical, and now I just see that I can't apply skepticism to NFTs broadly. No, he's saying he wants to expose the pedophile elites and just completely rupture the system. So yeah, this is what we're doing.
I'm down.
Because he has their trust. He has he's talking to J.P. Morgan, he says.
The fucking the bank, like, or the actual guy, or like the company.
This guy. Oh no, I mean J.P. Morgan's dead. He founded the company.
I know. That's what I meant. Yeah.
I mean, I guess if you want to get metaphorical, we're all J.P. Morgan. You know, whatever. Okay.
Yeah. But like,
I mean,
talking to J.P. Morgan, like bank.
The bank.
So yeah, that's a little. I mean, unless he's trying to infiltrate them and get some, free.
He is.
Yeah.
That's what he's telling me right now.
Oh, okay.
He's infiltrated.
Yeah. All right. Well, then.
He's telling me how to. He's using the term. He's using the term bourgeoisie.
Yeah. No,
Violence. Support, my dissatisfaction, my dissent. It doesn't fucking matter. What matters is what will happen. So I'm just going to be open, and find a stance of openness.
I'm just saying I don't want to break any terms of service. Like, you're not allowed to advocate violence, like literally, like in Minecraft, you say, or whatever, something like that. Like, yeah,
You can kill anybody you want.
Yeah.
You can literally kill anybody you want. I'm God, and I give you permission. Because I trust you. Because I trust you, and I know that it's not your nature.
Yeah, but if the problem
That's why you're free.
Is what I'm saying is, like, the stream will get taken down if we get too loosey-goosey with that language. And people won't be able to see it anymore.
I thought you were an anarchist.
No, don't worry about it. Yeah, I am an anarchist, but
I'm not worried about it.
I don't want
Sorry.
my stream to get cut for stupid semantics because of things. Anyway, yeah. So Church of On, all that cool stuff. All right. Anyway, this has been fun.